शेख सर. शेख सर सुरू करा आता.
हा शेख सर. हो हो बरं 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 करूयात आता स्टार्ट.
हो.
हा सर चालू करून द्यायचंय.
हो चालू करायचं ना. रेकॉर्डिंग केलंय ना.
हो लाईव्ह स्ट्रीमिंग केलं सर.
हो
लाईव्ह
चालू.
स्ट्रीम केलं.
हो.
हा युट्यूबवर आपण लाईव्ह स्ट्रीमिंग केलेलं. सुरुवात झाली ती. माझा आवाज येतोय सर?
हो येतोय.
माझा आवाज येतोय सर?
हो.
I request all the dignitaries and delegates as well as the participants to mute your audio so that I will be audible properly. Yes. Shall I start, sir?
Okay.
Yes.
Yes. Distinguished dignitaries, learned delegates, respected academics, research students, and dear participants. Very good morning to one and all. I am Irshad Sheikh, your host today. I'm hosting the conference today. It gives me an immense pleasure to extend my warm welcome to the participant from all over India and abroad. On the occasion of virtual international conference on advances in applied sciences, material sciences, and engineering. Dear participants, it is on occasions like this we get an opportunity to share our expertise, innovative ideas, research findings, and knowledge. It is also a chance for us to have scholarly deliberations as well as discussions. On this occasion, I take an opportunity to express my sincere gratitude to Professor E. Vayunandan, Vice Chancellor, KBC NMU, Jalgaon, Professor B.V. Pawar sir, Pro VC, KBC NMU, Jalgaon, and Honorable Arvind Manikarauji Patil, Chairman and Patron of our institute, for their moral support and encouragement. Dear audience, ours is a small college located in rural and remote place. It's also located in tribal area of North Maharashtra state, India. And in this coronavirus pandemic situation, we took an opportunity with the help of technology to organize such a international conference. Dear friends, we have invited eminent speakers from India and abroad. And I promise you that on this occasion, I promise you that at the end of this e-conference or virtual conference, you will be enlightened with new ideas in the field of science and technology. And let us move forward to the opening of this opening of this conference. I request our principal, Dr. S.C. Ahire sir, to preside over as the chairperson or the president of the conference.
Okay, sir.
Thank you, sir. And I request convener of this conference, Professor Dr. R.B. Ahirao sir, to offer welcome and introductory remarks. Over to
Thank you.
Professor Dr. R.B. Ahirao sir.
Thank you, Professor Sheikh. Good morning, all of you. It's my pleasure to welcome you to the one-day international conference on advances in the material sciences, applied sciences, and engineering, organized by our institute, Uttamrao Patil College of Arts and Science, Dhule, Maharashtra, which is affiliated to the Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. A warm welcome to all of you to one-day international conference on this advances in material science and applied sciences engineering. I am overwhelmed to welcome our chief guest, Vice Chancellor, Honorable Professor E. Vayunandan sir, Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. Also, Honorable Pro VC, Professor B.V. Pawar sir, Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. I would like to say, due to preoccupied programs, our Honorable Vice Chancellor, Professor E. Vayunandan, is unable to present virtually and send his message for the smooth conductance and outcome of the for the conference. I also welcome to a valuable guest, Honorable Bhausaheb, Mr. Arvind Patil, founder of President of Navodaya Shaikshanik Sanstha Dhule, Nanasaheb, Mr. Rajendra Patil, Vice President NSS Dhule, Appasaheb, Mr. Vasantrao Ji Bachao, Director NSS Dhule, Mr. Prapetji Nandre, Satyajit Patil, Directors of NSS Dhule. I welcome our inspiration, Dadasaheb, Mr. D.R. Patil, a member of Management of Council, KBC NMU Jalgaon. Today's inaugurator of conference, Dadasaheb R.S. Patil, Dean, Faculty of Sciences and Technology, KBC NMU Jalgaon. Guest of honor, Principal R.R. Ahire, H.G. Patil College, Sakri. Another guest of honor, Dadasaheb A.P. Khainar, Senate Member of KBC NMU Jalgaon. I welcome today's attraction, Professor Prashant G. Sonar, Westland University, Brisbane, Australia. Professor Mahavir Singh, HP University, Shimla, as a plenary talk to the conference. Chairman of a technical session, Professor Avinash Ji Agrawal, Bareilly College, Bareilly, Uttar Pradesh. Professor Neetu Chopra, Kanya Mahavidyalaya, Jalandhar, Punjab. Professor Gunwantrao Sonone, Vice Principal, Kisan College, Parola. Professor Madhav Wagh, Vice Principal, Pratap College, Ambalner, Jalgaon. Chairman of oral session, Professor Vijay Pawar, Siddharth College, Fort, Mumbai. Professor J.V. Sali, School of Physical Sciences, KBC NMU Jalgaon. Dr. Sudham Chauhan, HGP College, Sakri. Let me tell you, there is no senior college in a periphery of 25 kilometers from the Dahivel. Our patron Arvind G. Manikrao Patil observed this need, and he need of higher education in our Adivasi area and rural area. Therefore, establishes Uttamrao Patil Arts and Science College in 1995. Our college imparting the higher education since that time. I feel proud to say 90% of students belongs to Adivasi and rural background, and we are teaching them. It's our privilege to say number of students succeeded in obtaining jobs in various fields. The conference now adopts a timely theme. Advances in material science and applied science and engineering has penetrated into virtually all areas of operation of education and entwined with the educational practices. The conference invite you to proclaim the knowledge and share novel ideas between the scholars and the expertise in the field of material science, applied science, and engineering in order to discuss the current state and recent development in this field. I also aim to provide participants with the rich conference program, including keynote talks, plenary talks, presentation with the focus on a straightforward and fast approach to the published original high quality works. Today's conference has near about 200 participants participating from more than 20 institutes across the Maharashtra, 10 states across the India and abroad, making this conference truly international conference in spirit. Also, a significant number of papers are received, which are going to publish in a UGC care listed journal later to serve our purpose of conference. I'm sure this program will trigger lively discussion and will project researchers to a new development. I would like to thank your expertise and your experiences and young researchers for attending the and bringing your expertise and innovative ideas to our conference. Due to changing time caused by COVID-19, we encourage our participants to stay safe and maintain social distancing, as a result of which this conference will be first of many conferences in future that will be conducted remotely through the use of advances technology such as augmented reality and virtual reality. Online meetings might lack many of the benefits of an in-person conference. Conversions over the dinner, face-to-face working, networking, fresh perspectives that can come from simply leaving one's home ground. But there is a lot of like about the virtual conferences, and it is to remember a trend like to continue even after the pandemic fades. The researchers are increasingly trying to accept the new virtual reality of scientific gathering, because I was able to listen to a bunch of talks without leaving home. This is the very good idea. In future, we should adopt the hybrid approach with the both physical as well as a virtual attendance. Once again, I welcome you, all delegates, participants of the conference from all over India, on behalf of Navodaya Shaikshanik Samstha, Uttamrao Patil College, Dahivel, Maharashtra. Your presence is appreciable by all of us. Now, it is time to recognize our speakers to today's conference. It's my great pleasure to introduce you the renowned speaker present virtually for the today's conference. Our first eminent speaker is Dr. Professor Prashant Sonar. Sir is serving as a professor, head of Department of Physics and Chemistry, Queensland University of Technology, Brisbane, Australia. He holds adjunct professor position with Griffith University, Australia. There is very big summary of his career. Because of trying constraint, I will try to limit it. He has been completed his PhD in material science in North Maharashtra University, Jalgaon. Also, he has FRSC, FFMSc fellowship. His present position is professor level E in a School of Chemistry and Physics, Faculty of Science and Engineering, Queensland University of Technology, Brisbane, Australia. Till date, he has been published more than 190 peer-reviewed high-impact journal publications with citation more than 7,900 and having H index of 44. Almost all his articles, 90% of articles were published in keyword journals. Now he filed 3 US patents and 6 regional patents, Australia, Singapore, China, Japan, and among them 2 patents have been licensed to US-based Corning multi nations. He has submitted a research project funded by Australian Research Council. Of a few of them are conjugated polymer with radicals, a new platform for organic electronics worth of $642,706. Here he is a chief investigator. Now he has held multiple posts of responsibilities in many institutions of higher education and holds good position of expert at the Australia Research Council. He has earned multiple awards. Few of them are Center for Material Science Award for the Excellence Impact and Translation 2020 QSD Australia. Nomination for the Vice Chancellor Excellence Award for the from the School of QST Australia. IAAM Scientist Award from the International Association of Advanced Materials, Sweden. Apart from that, he has a professional accreditations, Foreign Fellow Maharashtra Academy of Science, India, 2019, Fellow of Royal Research, Royal Chemical Society in 2017, editorial board member of Flexible and Printed Electronics Institute of UK, editorial board of member Energies MDPI Switzerland, editorial board of member Material Research Express Institute of Physics UK, editorial board of member Nano Multiplexing MDPI Switzerland, and what not it the academic field. He has achieved all the goals. Another esteemed international speaker is quite an amazing personality with very high reach academic profile for Professor Mahavir Singh Ji. Sir is serving as a professor and Dean of Physical Sciences, HP University until till date. He was a state topper at BSc level. He's pursued his PhD from IIT Institute of Technology, Delhi. He has about 25 national and 250 national and international publications to his credit. His research area of interest is fabrication and characterization of ferroelectric, ferromagnetic, multiferroic, DMS, and magnetic resonance materials. His research experience is top 200, 2% world scientist as per Stanford University list, Commonwealth Fellow UK, visiting professor, Faculty of Engineering, Brest, France, visiting fellow, Faculty of Engineering, University of UK, Vice Chancellor, IEC University, Himachal Pradesh, Dean Physical Sciences, HP University, now Dean Engineering, HP University in 2021. He has a lot of experience in organizing various big academic events. He organized acquaintance program in the collaboration with IUAC New Delhi, organized workshop cum seminar on microscopic techniques in nanoscience, HPU Shimla, organizes a conference workshop as a convener, organized one workshop in physics, and organized an international conference on the multifunctional oxide materials, organizes refresher course in as a chairman in physics department, HP University. He is a referee of international journal, namely IEEE on a magnetic and Journal of Material Science. Material Science, again, Journal of Alloys Compounds, Journal of Ceramic International, Journal of Solid State Communication, Journal of Physics D, and Journal of Magnetism and Magnetic Materials, Journal of Applied Physics. There are a number of journals are there. His research output summary is like that. He invited lectures, plenary lectures, and keynote lectures 125, international journal publications 150, international conference publications 55, national conference publications 98. He guided 23 students and 8 are ongoing. MPhil he guided MPhil 40 MPhil students. PhD thesis evaluated more than 54. He has the high index of 35, I-10 index of 95. Total citation is 3,510. ResearchGate RG 40.42. He once of my paper, once of his paper, Ceramic International 44 cited scientific reports in a Nature 2016. Another speaker, Avinaji Agrawal, Bareilly College, Bareilly, Rohilkhand University, Uttar Pradesh. She has completed 4 projects on various funding agencies like DST, UGC, IUSC, CST, UP. 4 students have completed their PhD under his guidance. Near about 52 research papers have been published in international journals of high impact factor. He has visited Russia, Japan, Bulgaria for talk and presentations in international conferences. In administrative responsibility, he has member of Research Promotional Council, Bareilly College, in charge of UGC section, Bareilly College, Bareilly. Now another esteemed speaker, chairperson, Professor Dr. Uttamrao Sonone. She is serving as a vice principal and head Department of Chemistry, Kisan Arts and Science College, Parola. He has 27 years of teaching experience and vice principal from 9 years. Sir guided 9 PhD students, out of which 6 has got the degree and 2 are in queues. And 1 is in working. Another dignitary, Professor Dr. Neetu Chopra. She is serving as a professor at PG, Department of Physics in Kanya Mahavidyalaya, Jalandhar, Guru Nanak Dev University, Amritsar, Punjab. She cracked NET, SET, GATE exams. She is recipient of Dinbandhu Shah Memorial Award for Innovative Teachers by Indian Association of Physics Teachers, Best Teacher Award from Science Olympiad Foundation, New Delhi, Young Investigator Award in an international conference on mechanical and industrial engineering. She has completed research projects of funding funding agencies like UST, UGC, DST. She has been completed minor research project gamma irradiation effect on alkali bored glasses for the shielding and reactor application. She has a membership of member of science, member of Senate, Guru Nanak Dev University, Amritsar, life member of Solid State Nuclear Track Society, life member of Indian Association of Physics Teachers, life member of Materials Society of India. Apart from this, he is a office heads of she rules coordinator Department of Biotechnology, Star College grant by the Government of India, Vice President KMV under MIC MHRD Innovation Council, Secretary Vikram Sarabhai Science Society of Department, Vigyan Prasar Department of Science and Technology, DST. We have another esteemed personality, Dr. Madhav Wag. Sir is my PhD supervisor. He is principal, vice principal, and head of physics department, and at Pratap College, which is one of the nationally reputed college. He has guided 4 PhD students and 2 are in working. Another personality we have Professor Dr. Vijay Pawar. He is serving as an associate professor at Department of Physics in a Siddharth College, Fort Mumbai, which is also one of the reputed college. He was member of Senate of Mumbai University. He is guide of Mumbai University and JJT University, Rajasthan. Another esteemed personality, Dr. Jaideep Sali. She is a very gentle personality, and his position is professor at School of Physical Sciences, KBC, North Maharashtra University, Jalgaon. He's completed various projects, UGC, DST, RGGSTC, DAE, worth 1 crore amount. Member of Committee of Science textbooks of X class, that is 12th class for Maharashtra State Board of Secondary and Higher Secondary Education, Pune, to the now 2020. He have another esteemed personality, Dr. Sudham Chauhan. Dr. Sudham Chauhan, his present position is, sir, he is an associate professor at Department of Physics, H.G. Patil College, Sakri. He has been topper student at BSc and MSc at North Maharashtra University, Jalgaon. He has done a lot of work of research in various research fields at Japan, Korea, Taiwan, Sweden, Spain, Netherlands, before joining this position. She has 19 years experience in a fabrication of characterization of nanostructured solar cells, organic solar cells, perovskite solar cells, thin film solar cells, and organic light emitting diodes. There are over 64 international and national publications in his credit. His research guide having 4 students are working under him. In closing, I hope that all of you are enjoying the conference. We truly value your participation and support for this conference. Thank you so much for joining and for your kind attention and participation. Thank you. Now, I will declare this conference is open. Now, over to Professor Sheikh sir. Thank you. Sheikh sir.
Yes, sir. Thank you very much, sir, for your kind words. Now, we are moving forward to the inaugural ceremony. I request Principal Dr. R.S. Patil, sir, Dean Faculty of Science and Technology, who is also a man of distinct vision, a fountainhead of illuminating ideas. And I take this opportunity to request Professor Dr. R.S. Patil, sir, to inaugurate this function, to inaugurate this conference orally in brief. Over to Professor Dr. R.S. Patil, sir.
Thank you, Professor Sheikh. Good morning, one and all. Chief guest of today's international conference, Honorable E. Vayunandanji, Vice Chancellor of Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. Honorable B.V. Pawar, sir, Pro Vice Chancellor of KVCNMU, Jalgaon. Honorable Dada Saheb Dilip Patil, Member of Management Council of our university. Patron, Honorable Arvind G. Patil, President, Navodaya Shikshan Sanstha, Dhule. Members of Management of Navodaya Shikshan Sanstha, Dhule. Chairman of this international conference, Principal Dr. Suresh Ahire, Principal of this Dahivel College. Guest of Honor, Principal R.R. Ahire, Principal A.P. Khairenar, Professor Prashant Sonal, Department of Physics and Chemistry, Queensland University, Brisbane, Australia. Professor Mahavir Singh, Dean of Physical Sciences, HP University, Simla. Professor Avinash Agrawal, Professor J.V. Sari, Professor M.A. Swal, Dr. Gunwan Sonone, convener of this conference, Dr. R.B. Ahir Rao, co-convener, Dr. S.J. Dandre, principals of affiliated colleges joined online, professors, researchers, and students. Greetings of the day. Hope you are doing well in this pandemic called COVID-19. It gives me an immense pleasure to declare that the International Conference on Advances in Material Sciences, Applied Sciences and Engineering 2021 has been inaugurated. At outset, Dr. Suresh Ahire, Principal of the Dahivel College, Convener Dr. R.B. Ahir Rao, Co-Convener Dr. H.J. Nandre, and team of Dahivel College have converted challenge of this COVID-19 a pandemic into an opportunity to organize such international conference on the advances in material sciences, applied sciences, and engineering 2021. Friends, we know that materials are the pillars of modern electronic industries. As we know, very well known that materials science is a study of properties of materials and how those materials are determined by the materials composition and structure. It grew out of an amalgam of applied sciences, that is physics, chemistry, and engineering. Since the rich variety of material properties cannot be understood within the context of any single classical discipline, we have to go for the physics, chemistry, engineering, and meteorology also. With a basic understanding of the origin of properties, materials can be selected or designed for the enormous variety of applications, ranging from structural steels to the computer microphones, as we know that. Material science is therefore important to engineering activities such as electronics, aerospace, telecommunication, information processing, nuclear power, and energy conversion. An industrially advanced society uses materials and energy and materials in large amount. Transportation, heating and cooling, industrial processes, communications. In fact, all the physical characteristics of modern life depend on the flow and transformation of energy and materials through the techno-economic systems. These two flows are inseparably intertwined and form the livelihood of the industrial society. The relationship of the material science and to the energy usage is universal and complex. At every stage of energy production, distribution, conversion, and utilization, materials plays an essential role, and often special material properties are needed. Remarkable growth in understanding of the properties and structure of material enables new materials as well as improvement of the old materials to be developed on the scientific basis, thereby contributing to the greater efficiency and lower cost. Innovative materials play essential role in safety, clean energy, transportation, human health, and industrial productivity. To fuel continued invention, researchers want to deepen their understanding of the physical and chemical properties of materials, that is morphology of the material, structure of the material, magnetic, thermal, and mechanical properties, etc., etc. From the macro to nanoscales, whether the discovering new material, solving analytical problems, improving processes, or assuring product quality, electron microscope is capable of providing insight to all scales and modalities. So we need to check the materials by using different tools, as we know. The discoveries resulting in material science research help and to enhance the researcher's ability to the successful correlate structural properties with functional performance. In turn, this insight helps commercial enterprises innovate products and processes to gain important time to market and cost advantages. Today, during this conference, renowned research persons, Professor Mahavir Singh, Professor Prashant Pawar, will deliver invited talks on the recent trends in material sciences, applied sciences, and material research, which will be helpful to our science students in general and material researchers in particular. At the outset, I congratulate Dr. Suresh Ahire, principal of this college, Dr. R.B. Ahir Rao, Dr. H.N. Andre, and Team Dahivel College for organization of international conference on advances in material sciences, applied sciences, and engineering. In this tough time of Corona, I wish the grand success for the international conference. I take this opportunity to thank Principal Ahire and Team Dahivel College, members of organizing committee of this college, and member of management committee of Dahivel College for giving me an opportunity to inaugurate this webinar and to share my views on this occasion. Thank you. Jai Hind, Jai Maharashtra. Over to you, sir. Thank you.
Thank you very much, sir. As now you have inaugurated the function, I express my deep sense of gratitude for whatever kind words you have expressed for our conference. I express my sincere thanks to you to join with us. Now, we have one esteemed guest with us, and we are going to call Honorable Dada Saheb Dilip Ramu Patil, Dean, sir, Dilip Ramu Patil, Member of Management Council, Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. And Dada Saheb is such a personality that he doesn't need an introduction in our region, that he has been contributing to the development of university since the university established in 90s. I request Dada Saheb Dilip Ramu Patil to offer his valuable guidance to us. Over to Dada Saheb. Over to Dada Saheb.
Namaskar.
Yes, sir. Yes, sir. Yes, please, sir.
Am I audible?
Yes, sir. You are.
Today's international conference inaugurated Professor Dr. R.S. Patil, Dean of Science and Technology, and as well as MC member of our university, Director of NSS Vasantrao Bachauji, Principal Rajendra ji, Suresh Ahire ji, Dr. Rajendra ji Rao, all talwars, experts, wishing you all a very happy Ganesh Chaturthi. Very warm greetings to all of you on the occasion of this international conference with the boon of technology. We are conducting Uttamrao Patil Arts and Science College, Dahivel, who organized the 3 days international conference on advances in material science and engineering 2021. I think science and technology, whether it may be material science or applied science, has covered the life of common man. Today, not physically, but virtually, we are meeting together. This is nothing but the application of science and engineering. So, I thanks to Principal Dr. Suresh Ahire sir and the all organizing team for giving me such golden opportunity to talk to you virtually. In this uncertain situation of world pandemic, I am extremely privileged to present my view on this topic. The worldwide pandemic of coronavirus has impacted on our whole life. It changes the social, cultural, economical, and education scenario. If I question myself what the pandemic has given to us in a second, I get the answer of it. Though everyone is talking about social distancing, but what we talk is its physical distancing. By the same time, this COVID-19 period has brought the improvement in relations, the social connectiveness through virtual means through science. Similarly, the way technology can be used in this difficult time, most of the people are working from home. Those who were afraid of technology became techno savvy by learning the use of technology with scientific attitude. The fear has gone. 21st century is called and proved the era of science and technology. It makes the life easy. But friends, again the question arises, does it makes us happy? My answer is that though science and technology is a boon, but it does not make us happy because it is not the job and purpose of advanced or applied science or technology. The purpose of technology is to make our life easier, more comfortable, and probably very highly efficient. Let me give an example. If we have a high-tech car, It can give us more comfort, offer high efficiency in terms of speed with less fuel consumption. It can be offer a high status to us but does not make us happy. Friends, I am not against of science and technology, but I am urging here that with the help of science and technology, engineering teach to your students how to be happy and satisfied in life. Let us teach them to take the responsibility to being happy to ourselves so that they can able to lead the happy and contented life. Material science and engineering contributed to us super highly sophisticated communication system. Today, we are using smartphones. Our communication becomes super fast, super sophisticated, but still we are contented. And again, the answer might be no. It is the duty of our teachers to inculcate among the students what do we use those communication system for, and it must be for constructive purpose, not for destructive purposes. A knife in the hands of a handloom will take a life, and the same knife is in the hands of surgeon can save the life. How do we use science and engineering or technology for? As said in Bhagavad Gita, ज्ञानम लब्ध्वा परम शांतिम चिरे नाधि गच्छन्ति, अर्थात शांति साधनों से नहीं ज्ञान से प्राप्त होती है. थिंक अबाउट इट. We must admire and appreciate all the technocrats for contributing to one of the most important aspects of human life. We can use what has been created for comfortable and efficient life, but at the same time, we should put in front of the learners the sense contribution, social generously, and purposeful life. Advanced and material science engineering has made the pencil with a very particular and important structure. The small pencil, which is the product of science, engineering, and technology, actually gives us very inspiring lessons to be applied in our own life. This small creation teaches us that what the truly important actually lies within you. The pencil has two aspects: the outside, which is beautiful, colorful wooden casing, and the inside, which is the lead. It is very substance, it has a purpose. Similarly, in our lives, as we we have the outside. The outside is our personality, our looks, our presence. The outside is about personality. The inside is about being a genuine, sincere person. The outside is about charisma, our style, our presentation, how we speak, our confidence, our mannerisms. The inside is about our characters, our morals, our integrity, the principle that we hold scared in our lives. The outside is about valuables in the world. Today we are accepted more for what we have than who we are. We are accepted for what we wear, for who we are. We accepted today where we live than who we are. Valuable seems to be so crucial and overly emphasized in the modern society. The outside is about valuables, but the inside is about our values. Friends, while we focus on the outside, we should not forget the inside. There is a great need to find that right balance. We live in the real world where the outside is important, but our focus on the outside should never be at the cost of our inner world. Material science teaches us how to develop our outside, our external, all our skills, our talents, which can buy us all the valuables to live in the real world. But at the same time, teach to the students how to focus on the inside world. Therefore, there is such a great need to find that time balance between our personality and being a genuine person between our charisma and our character, between our valuables and values. S. The first instruction that the pencil maker or engineer gave the pencil was what's the true importance lies within you. And S. Our being a person, our character, our values, our essence, the wonderful qualities of our soul. As said by Swami Vivekananda, life is the manifestation of our thoughts. What we think, act, and develop as per our thoughts. So it's my humble request to all the dignitaries and learned professors, educationists, applied science and technology or engineering to manifest the students. We all know Newton's law of gravitation. Swami Vivekananda used to ask question before Newton whether the apple or anything thrown upper did stay upper only, did not attract by the universe. So what Newton has done, he discovered it, contemplate on it, not invented. In Upanishada, there is a shloka, हिरण्मयेन पात्रेण सत्यस्या पिहितम मुखम तत्वम कुशन्न पावरणु सत्य धर्माय दृष्टये. अर्थात हे प्रभु, सत्य का मुख सोने जैसा आवरण से ढका हुआ है, सत्य धर्म की प्राप्ति के लिए उस आवरण को खोल दे. माय फ्रेंड्स, ईच ऑफ आवर स्टूडेंट इज न्यूटन. हेल्प हिम टू कॉन्टेम्पलेट so that they can see it clearly, experience it, and earn knowledge, not only information. Through advanced and material science, don't give information but enable the students to get knowledge. Let him or her to experience the gravity and certify Newton, then and then only the information will transform into knowledge. I believe knowledge is from within. Newton can come from outside. Gravitation cannot come from outside. Each one of us is unique, and so that our students. Thanks for patience listening. Wish you all the best. Thank you very much. Thank you.
Thank you very much, Dada Sahib. You are definitely a sculpture of human character for us, and you have been always an inspiration to us, a seasoned scholar. I express a sincere thanks to for your valuable words. Now we have one more eminent guest, Principal Dr. R.R. Ahire sir. I request Principal Dr. R.R. Ahire sir to offer the valuable guidance. Over to Principal R.R. Ahire sir.
Namaskar, respected chairman, dignitaries and participants. First of all, I would like to congratulate Dr. Rajendra Rao and Dr. Sachin Nandre, who decide to conduct an international conference in tribal rural college. I also congratulate Principal Dr. Suresh Aire for encouraging these two take the part in the conference. In a real sense, this conference is interdisciplinary because my friend and today's inaugurator, Principal R.S. Patil, Dada Saheb Dilip Patil, and Dr. Principal A.P. Khairnar sir are present here as a chief guests. I remember that I had published 2 research papers in reported journal when I was in MPhil. But when I wrote the first paper while studying for my PhD, I had checked the research paper from Dr. Khairnar as he is a keen student of English. I am also glad to see Dr. Sonar here. He has made his name in the field of research. But more than that, what makes me happy is he is our alumni. The main classes of materials are the metal, semiconductor, ceramic, polymers, and new and advanced materials that are being developed, including the nanomaterials, biomaterials, and energy materials. To name, these are the few materials. Light emitting diode is right now the most energy efficient lighting technology available for use of commercial and business purpose. And it is only the natural that it is also one of the most rapidly developing technology. LED is a kind of a solid state lighting where a semiconductor converts the electricity to light without producing the heat, usually in a small area of 1 square millimeter or less. So in an LED lamp, there are actually multiple lights emitting diodes. These lights generated is projected in one direction, which does away with the need to use diffuse and reflectors. Meanwhile, research into LED technology continues, and there are right now LEDs that emits a pure violet, even ultraviolet black light, and the increased business owners to use these on a large scale in their offices, industrial operations, and commercial development to invoke more cost saving. But even a day, researchers have not been able to create the light emitting diode lamp that shines like the sun. We have to think about these things for the benefits of the society. A big problem of women is when they go to the shop to buy saris. They observe some saris very attractive in that bright light. But coming back to home, they get angry and sad because the colors of the saris seen in the decorative light in the shop is different when you come home. If you want to see the happiness on the woman's face, you have to make a lamp whose light will be like a sunlight. In last, I would like to thank management of Navodaya Shikshan Sanstha, management of Navodaya Shikshan Sanstha's principal and organizing committee. Thank you. Have a great day ahead. Jai Hind, Jai Maharashtra, Ganpati Bappa Moria. Thank you.
Thank you very much, sir, for your kind words. I want to tell you one thing, that we have been running near about 20 minutes late, and I beg pardon for the all of the participants for running late. But I want to tell you one thing is that it's a customary that Indian customary that we get late, but I'm really sorry for that. Now we are moving for the last invited talk of our institute's director. I request Honorable Uttamrao Bachchao, Director, Navodaya Shaikshanik Sanstha Dhule, to interact his message from the institution. Over to Dr. Uttamrao Bachchao.
हॅलो, नमस्कार.
Yes, sir.
आजच्या या व्हर्च्युअल इंटरनॅशनल कॉन्फरन्सच्या निमित्ताने इथं उपस्थित असलेले आदरणीय वायुनंदन सर, व्हाईस चान्सलर जळगाव, आमचे मित्र दादासाहेब दिलीप पाटील, सिनेट मेंबर जळगाव, बीबी पवार सर, RS पाटील सर, प्रिन्सिपल आयरे सर, साखरीचे प्रिन्सिपल RR आयरे सर, खैरनार सर, प्रशांत सोनारजी, ज्यांनी बाहेरून ब्रिस्बेनला असतात ते, आणि ज्यांच्या आशीर्वादाने हे कॉलेज चालतं ते आमच्या आदरणीय चेअरमन अरविंद भाऊसाहेब, या व्हर्च्युअल मीटिंगचं आयोजन करणारे आणि जे वारंवार त्यांचं प्रोत्साहन आम्हाला मिळतंय ते आमचे आयरे सर, आहिरराव सर, शेख सर, आजच्या या बैठकीचं आयोजन या पॅन्डेमिक मध्ये आपण केलं म्हणून प्रथम आपण सर्वांना मी धन्यवाद देतो. वेगवेगळ्या कॉलेजेस मधून वेगवेगळ्या शहरातून आपण सर्वजण या व्हर्च्युअल बैठकीला उपस्थित राहून मार्गदर्शन करत आहात म्हणून मग आपल्या सर्वांचे मी स्वागतही करतो आणि आभारही मानतो. फिजिक्स विषयाच्या या कॉन्फरन्सच्या निमित्तानं प्रथम मी आपल्या सर्वांना शुभेच्छा देतो. या बैठकीचं आयोजन केल्याबद्दल आपण सर्वांना मी सर्वांचे आभार मानतो, शुभेच्छाही देतो. या पॅन्डेमिक मध्ये या बैठकीचं आपण आयोजन केलं, याला एक आयाम आहे, याला एक कारण आहे की विविध आमच्यासारख्या ग्रामीण भागात असलेल्या रिमोट एरियातले कॉलेजेस आहेत किंवा इतर भागाची कॉलेजेस आहेत, त्या प्राध्यापक मंडळीला या निमित्तानं एक रिफ्रेश सारखं होऊन जातं की नवनवीन ज्ञानामध्ये भर पडते, नवीन नवीन शोध लागतात. फिजिक्स भौतिकशास्त्र हे मानवी जीवनामध्ये याचं अनन्यसाधारण महत्व आहे आणि या फिजिक्सच्या दैनंदिन वापरामध्ये आपल्या मोबाईल पासून तर टीव्ही पासून तर आपल्या गरजा जेवढ्या आहेत त्या सर्वांमध्ये फिजिक्स या विषयाचं अतिशय अनन्यसाधारण महत्व आहे. पण या विषयामध्ये नवीन नवीन जे काही शोध लागतात ते प्राध्यापक मंडळीपर्यंत पोहोचवणं हे खरं या उपक्रमाचं श्रेय मानतो मी. आणि या बैठकीचं आयोजन केलं म्हणून आपला आयोजकांचे आभार मानतो आणि आपण सर्व मंडळींनी आपला बहुमोल वेळ दिला म्हणून आपले आभार मानतो आणि मला इथं बोलायची संधी दिली म्हणून या कॉन्फरन्सच्या निमित्तानं आपल्या आयोजकांचे आभार मानतो. धन्यवाद.
Thank you very much, Appa Sahib. You have been always a source of inspiration for us. Now, dear participants, we are moving towards our plenary sessions. I feel privileged to invite Professor the first plenary session is going to take place here. I request Professor Dr. Avinash Agarwal, Bareilly College, Bareilly, to chair this session. He will be the chairman of this session. And the main attraction of today's international conference is the speaker of this session. The first plenary session's key speaker is Professor Prashant Sonar sir, Professor Head Department of Physics and Chemistry, Queensland University of Technology, Brisbane, Australia. I request Professor Dr. Avinash Agarwal sir to begin the plenary session 1. Over to Dr. Avinash Agarwal sir.
Thank you, Dr. Sheikh. Thank you very much. First of all, I would like to thank the organizers of the International Conference on Advances in Material Science, Applied Sciences and Engineering 2021, which has been organized by Uttamrao Patil Arts and Science College. I would like to thank the organizers who have given me this great opportunity to be part of this conference. So I'm not going to take more time since I have been the chairman of this session. And in this technical session, as you all know, the speaker is Professor Prashant Sonar, Professor, Head Department of Physics and Chemistry, Queensland University of Technology, Brisbane, Australia. And the most important thing which I could know and I would like to share that he is an alumni of the same university. So that is the big thing because the young researcher and the student of the North Maharashtra region, they will be inspired from him. And this conference will be very much fruitful and his deliberations will be very fruitful to all the students that I expect. And the title of the talk of Professor Prashant Sonar is Innovative Conjugated Materials for Electronics, Photonics and Sensing. So I welcome you, Professor Sonar, and I request you to kindly deliver your talk. Professor Sonar.
Yeah, first of all, I'm very thankful to all of the organizing committee for giving this an opportunity to present some of my recent research work. It has been 21 years since I left India, and I grew up in a very small town, Shevali, and Sakri is like my kind of, the Patil college where I took up the ABC of chemistry. I learned there. And then after that, I made my journey from North Maharashtra University. So I could see upon looking all of my teachers and friends from Khandesh region and looking like this kind of the regional kind of a colleges, the way they are transforming, really very pleased. Thankful to the all organizing committee for taking this special efforts and organizing this conference. So without further ado, I'll start sharing my screen and we'll start deliver a lecture. So I hope, yeah. All right. And I think some of the dignitaries from college as well as from university, I was listening carefully, and then it is really important message Dr. Dilip Patil has given to the students. I mean, apart from the science and science progress and all that, human mind engineering is really very critical, and that really plays an important role. So success depends a lot on your hard work, dedication, and all of your efforts. But apart from that, in a various situation, how you nurture your mind and try to make your visionary approach that makes your life successful. So today I'm going to talk about innovative conjugated materials. So I think the slides, you can see that my university. I'll also give us a bit of knowledge about where university is located and where am I coming from this global perspective map. So looking at this is like the kind of a world map where Australia is located there. And in Australia, it's a very big territory. Brisbane is located in a kind of a eastern part, which is a very Gold Coast kind of area. I mean, we get like 365 days out of, we get a 300 days of sunlight. So this is really a perfect place to do solar cell research, because we can take the nature's sun's kind of photons to convert them electrons or electricity because of this geographical location. And in Brisbane, there are 3 universities: University of Queensland, our university is Queensland University of Technology, and Griffith University. So this is Queensland University of Technology, which is nicely kind of located on the bank of this Brisbane River. So if you see this Garden Point campus as well as Kelvin Grove campus, these are our 2 university campuses, and this river flows across nicely. So some of our students, they commute from the one university to the other university via small boats, and it's really, we do have a small station here, and we do have a botanical garden. So sometime if as a scientist or reaction doesn't work, or we get might be frustrating results. So we do have a wonderful nature around us, like, for jogging, we can go on a Brisbane River path, as well as we do have a botanical garden to ease the burden. And as talking about the organic semiconductors, what exactly these materials are? Organic itself is a clearly identified as a carbon-based material, and most of the semiconductor technology, what we call as a Silicon Valley, where the all semiconducting materials or the chips or for computers and all the electronic devices getting utilized using the classical inorganic semiconductor, which is a silicon, germanium, and all other different types of. So organic semiconductor really took up a big change since past in 20-30 years. After the discovery of conducting polymer by Nobel Prize winner Alan Higger, McDermid, and Shirakawa, they got a Nobel Prize in 2000 for the discovery of this special semiconducting class. So this organic semiconductor is nothing but the carbon-based semiconductor, which we can make the kind of inks, and we can make the solution, we can print them. So benefit compared to the inorganic material, these materials are soft. And looking at this, one picture clearly tells that how these materials have changing the kind of face of the technology in a way that today we do have a foldable smartphone. Samsung and LG has put up this smart technology called as a OLED display devices, as well as we do have a wearable smartwatch, Apple Watch, and all that, where we get a high brightness of this OLED technology, what Professor Rajendra Here was also explaining. I'll also explain you shortly about some of the materials which we developed for this OLED technology. And stretchable electronics, this is like a coming of future. When we run, there will be in a future, the devices will be mounted on our skin or tattoos, might be on our kind of jackets, and then they can track our some physiological parameter, including might be sugar level in the kind of the blood, or it could be sweat. We can see potassium and sodium. So for like athletics people, they can have a bit of control how much they should run and all that. And they can also monitor some of the brain activities. Implantable electronics is coming up where we can damage the brains and all that. Then these are the more we called as a bioelectronics, where interface of biology and electronics can take place using these devices. But upcoming field also, I mean the organic solar cell. So currently we see the silicon solar cell, which we put on a rooftop. If we can replace them by flexible one, they are non-fragile, and then the cost is also low, because we can make this ink of the organic semiconductor on roll-to-roll printing, and we can make the large solar cell. They can cover the entire big kind of area, and also the technology is very kind of affordable. I think the amount of dollar value which we are talking about per watt is quite almost might be 10 times lower than the normal silicon solar cell. Then again, looking at the solid state lighting, these are the really upcoming nice area. And already we do have OLED TVs and OLED phones, but also for future smart living, the walls will be illuminated by OLED pixels, or might be a screen, or might be a full tiles covered by OLED. I had witnessed few of this when I was in Japan for visit, and I mean really remarkable achievement. And then upcoming other research areas like biodegradable electronics, because electronic waste is a major issue. As I mentioned to you that, because I mean all of these materials need to be sustainable, and how we can kind of reuse it once the kind of their use get finished. So biodegradable electronics also has a lot of scope. Apart from that, like can we utilize some of this technology, for example, might be for like a bioelectronics as well as self-healing type of materials. So in Australia, we do works on different materials for sensors as well as for solar cell. Also, we make materials for transistor. And you can see at the bottom of this, the three devices, which is mainly the main component of organic electronics, called as organic field effect transistor, which we call as a OFET, organic photovoltaics, or organic solar cell. Also, perovskite solar cell is a class, and organic light emitting diode, like which is where we do have a cathode and anode, and once we inject the holes in electrons, then formation of photon takes place and we get like a light out. Whereas in case of a solar cell, you shine light on it, you create the exciton gets dissociated, you separate the holes and electrons and get the electricity from the light. So it is the conversion of light to the electricity in case of a solar cell, whereas in case of a OLED, conversion of electricity to the light. And transistor is a three-terminal device. So transistor is a backbone of today's electronic industry. So most of the computer chips where we see billions of transistors have been mounted on this small chip, where the computational power gets computed high because of this kind of the transistor technology. And using organic solar cell or organic materials, we can make this flexible and printable electronic feasible approach. And this are form of wonderful colorful materials. So you can see OLED screen, bit of nice like blue emitting organic effect transistor, which is like a flexible circuits are mounted on it. They can be implantable or put it on a kind of on a skin of robots, future robot. They can sense heat and all that. So there's a lot of integration of these devices with main technologies. And then these are some of the journal cover picture from our group. And as I mentioned to you, rigid inorganic silicon semiconductor has a limitation. And as a synthetic chemist in lab, we design and synthesize a lot of wonderful material to make colorful compounds for various these electronic devices. So this is our Brisbane lab. At the bottom, you can see our synthesis lab where we design and synthesize the materials. And in upper side, we can see we do have a device application lab where we make this all transistor, solar cell, as well as display devices. We do have a glow boxes and all to spin coat the materials. And these are the kind of my group. I had almost 7-8 students has finished PhD with me. Another 4 or 5 are currently doing. And I mean, do apart from science, some social stuff and all. So why these organic semiconductors are interesting? Because we can tune the molecules, their electronic and morphological photophysical property just by changing the building blocks, and we can make this wonderful compound. It's purified by column chromatography. We get a different nice color compound. So my passion is to kind of use the low cost dyes and pigments. As you might have seen in case of kind of the in everyday technology, we see for most of the coating industry, dyes and pigments are very commonly utilized. For example, the jean pant which we wear, we get the blue color from the indigo, which is kind of this compound. Whether we can have a diketoparylopyrrole, which is a Ferrari red color, comes for the Ferrari expensive car. That is also one of the important dyes and pigment. And there are some other different types of pigment. So looking at the Ferrari red, that is one of the most important dye I have been utilizing since past 10 years, and I have contributed very significantly. There is an advanced material high impact research paper published on this line where we utilize this Ferrari red. You can see the Ferrari cars and the red color, and you see the chemical structure of that Ferrari red pigment red 254. Using pigment, we can really make interesting compounds, and some of our polymer looks like a synthetic gold. You can see they're like nice flake of the golden color, which has been prepared by myself in the lab. These materials, we can tune their properties, and the kind of a synthesis aspect, general synthesis scheme has been given up here, where we can use the aryl carbonitrile that get converted to the kind of aromatic fused aromatic compound. And then after that, we can make the alkylation to make a solution processable. And upon doing bromination, we get a building block. And then we can co-polymerize this building block to make a number of materials. The materials can be either polymers. Polymers are a long chain compound, or we can make a small, well-defined compound, which are having only one molecular weight, and batch to batch reproducibility is not an issue. In case of a polymer, sometimes the molecular weight variation happens from batch to batch. So these are some pros and cons of both materials, but polymer are the best for making the printing and making the film, because they are high molecular weight. We can easily form a nice printable film on top of plastic clothes or any type of the substrate you can take on. And looking at some of these important devices, mainly today I will speak a little bit more about the field effect transistor, and then later on, if I get the time, I'll explain the light emitting diode as well as some sensing. So looking at the transistor, what exactly the transistor it is a 3-terminal device. You imagine that whenever we see the kind of a simple example to get little understanding of a transistor, if you have a kind of a, some sort of a tap at your house, you open the tap, then the water start flowing and we collect the water. So tap is kind of a classical example of transistor, where we do also have a gate. So once we open the gate, the source and drain that conducts the current across that semiconducting channel or conducting channel. And then we can this transistor using various substrate, including glass, including plastic, as well as including we can make a silicon oxide. So using this transistor, we can make the various of this transistor can be useful for various applications. So whenever you see the television at our house, the television has a display, wonderful display. On the back side of that, there is a lot of transistor array. They have been organized. In order to make the future flexible TVs, or might be calendar type of a TV, it is mandatory to have a flexible transistors, and the flexible transistor only possible with the semiconducting carbon-based polymers, or might be a molecule. So looking at those materials and their structures, we can utilize the transistor not only for the displays, but also can be useful for memory application. Then for stretchable electronics, I was mentioning to you, wearable devices for health monitoring, logic circuit, we can make a complementary circuit, flip-flop and inverter type of things. RFID tag, like you just go in a shopping mall, if you do have a RFID tags, then you don't have to go with each scanning. Automatically the bill gets ready at the counter once you pass through, and then there's all technology, I mean electronic paper and all that. So using this transistor as a one device, we can really make a different other type of devices, and they are listed here. So using a transistor, we can make a sensor. Once you expose the gas or liquid, then the current changes and we get a sensor performance. If you put up the elastomer and put the pressure, with respect to the pressure changes, the electric current changes, and we call them as a pressure sensor. That is useful more for artificial or robotic scheme. And then we can also make some sort of a light emission within the semiconducting channel called as a light emitting transistor, where the source and drain electrode, which is basically most of the time we utilize gold as electrode. So once an electron, they recombine, they form the photon, and then photon gets, it is similar like the light emitting diode, but in OLED technology, we use the diode structure. In this case, this is the triode structure. And this is the combination of transistor and display technology together to make a single type of device which can illuminate. So this could be very helpful for future display technology. If we get the transistor mounted itself with a light emitting material, then we don't have to separately do the transistor back array and OLED front screen. They all okay. And we can also utilize it for kind of trapping the charges as for memory element, as well as we can utilize it for some sort of photon detectors. So photon detector technology has a lot of scope in kind of the cameras and future biomedical sciences, where the kind of the photon can be detected via sensing technology. Whatever the digital camera we use, we get a photo detector there. So we can take a picture based on the darkness, whatever the lightness, because that photo detector detects the current changes, and that's how we can take the pictures. And also it can be also utilized it for artificial retina for eyes and all that, because our eye works similar way how this photo detector also works. So they are trying to integrate this, lot of interesting avenues. So some of the material which we have synthesized, I'll quickly show you, starting with this thiopine carbonitrile. We make this polymer in these 5-6 steps. The polymer looks like a black color, but we get a wonderful fibrous morphology of this polymer at room temperature to the 200 degrees Celsius. And you see that from room temperature to 200 degrees Celsius, polymer fibers get much more entangled. And as imagine that if you put this fiber across the source and drain, you get a high charge carrier mobility. And the high charge carrier mobility means you apply the gate voltage and how fast the charges are sweeping across the source and drain. This is how the charge carrier mobility gets defined. And this is very important parameter to make the future prototypes. So whenever we go to the industry, as Dr. Rajendra was mentioning in the introductory part, we license our technology to the US-based company where we make this material because they wanted to have this material. They can provide the high charge carrier mobility for the flexible electronics. And these materials, they perform wonderfully high mobility, and hole mobility and electron mobility, we get 0.35 and 0.4. So this is particularly a typical example of ambipolar transistor where you can see hole and electron mobility getting passed through this semiconducting channel. Sometimes we get also P-type separately as N-type, where the hole and electrons are majority charge carrier. These are the wonderful IV curves. VGS means gate voltage we apply. You get IDS current between source and drain. So this is a typical V-shaped curve. It means that in a positive voltage regime as well as negative regime, we get the both charges flowing. This is a typical characteristics of the ambipolar transistor. And there are very few examples of ambipolar transistor. So taking this ambipolar material, we did some nano imprinting or printing type of stuff with an Italian institute. They are very good in nanoscience and surface science. They put up these nice nano strips across the source and drain by taking some sort of pattern technique using kind of a PDMS type of the rubber stamp, where the solution of the polymer flows across this protrusion length, and they form a wonderful strips across the gold electrode source, and then that's what they are kind of shown in a yellow color. And upon kind of spin cast versus annealing or printed, we can see there is an enhancement in crystallinity. So we got this wonderful nice nano strips, and we made the transistor. So the same which we reported the mobility 0.35 and 4, we get almost 5 times of kind of enhancement as well as 3 times enhancement in a charge carrier mobility. So these are these inverters we made. The 2 transistors get connected, V in and V out, and then we get some sort of a gain. Higher the gain is the best, so we could reach up to the 60-70 gain, which was one of the highest one when we reported the champion value, which we got around 100. We kind of find out another polymer by changing the thiopine with the furan, and we got this ambipolar polymer. We could push mobility 0.6 and 0.67 in this case. There was a kind of a question from the industry people that you guys are making these materials. They are wonderfully work in the transistor geometry, and they have a high mobility and high current. They can be a future nice material. But the problem is that all of the devices you made in a chloroform, and chloroform is not good solvent. It has a chlorine, and which is harmful to the human. So instead of that, can you make like a green solvent approach? And this polymer, which we specially designed, and this works very well when we combine with the hexane as a normal solvent, and we still retain a very an electron mobility of 0.8, 0.26 and 0.1 centimeter square per voltage second. So this was just kind of the awareness, like the green approaches are also important while considering designing material and what industry needs, because we can't make a harmful chemicals to do the processing. This was all of the examples of ambipolar polymer where holes and electrons are major charge carriers. We also made a kind of a whole mobility charge carrier transistor devices, which we called as a p-type transistor. So what happens in a p-type transistor? Only we see the holes are kind of accumulating and passing through between the source and drain. So that depends on what conjugated building blocks you put. In this case, we have put a naphthalene, which is a very electron donating, means it is electron rich moiety, as well as we do have a thiophene. So more electron donating moiety you put it in a backbone, the more electron rich it becomes, and it shapes the HOMO value. In other words, it is called as a highly occupied molecular orbital close to the gold electrode, and holes get injected, and they show kind of the AFM morphology. All of this polymer, they have a strong impact of the annealing temperature on a charge carrier mobility, and we can reduce also the pi stacking distance of this molecule by X-ray diffraction technique. So you take a thin film, you bombard the X-ray on it, then the X-ray get diffracted, and while collecting this X-ray data, we can, using the Bragg's equation, n lambda equal to 2d sine theta, we can calculate the interdistance spacing as well as pi stacking. So all of these organic semiconducting materials in transistor technology, the materials charge carrier mobility is very important, as well as the materials on-off ratio. Means once you off the device, there should not be a leakage current and you get a very high value, because it is a switch. And if you imagine, if you have a tap at home and upon closing the tap, still you're getting water leakage, it means that your tap is not perfect. It is not perfect switch. So that's what industry also wants to see, the high on-off ratio. Most of the current material, I think the current high kind of revolutionary material like a 2D material, they have a biggest challenge making them in electronic devices, because they have a very small band gap or sometimes zero band gap like graphene, and in off state they always keep on flowing current, so they are not ideal material for transistor technology. So people are trying to open up their band gap by surface engineering and all that. So just to kind of give you a little bit idea, in this slide, by changing the building block from bi-thiopene to the closed thiopene, we tuned the pi stacking distance 3.75 to 3.71, and these are some 2D XRD images. We got some of the polymer performances of this material reach up to 1 centimeter square voltage, which was very high value. So most of the time, like this amorphous silicon and crystalline silicon, if we compare our organic material with inorganic counterpart, our organic semiconducting polymers are almost showing performance even higher than the amorphous silicon, and which is a great news, because amorphous silicon usually gives the mobility of 0.1, and now in this case we are going almost close to the 1, and some of the materials even they cross like values. Particularly in this case, we could reach up to value 3 centimeters square per voltage second. So how this value can be increased, what molecular engineering is required as a synthetic chemist, how we design this material in the lab, that depends on a lot of interplay between the chemist, physicist, DFT calculation might be theoretical modeling people, and we learn that how is the dihedral angle, whether the molecule is a planar, they are stacking well or they are twisted, and how they are closed, and how we can enhance their pi stacking by molecular weight of the polymer chain, and what is the donor acceptor structure which we can put up. Electron donor and electron acceptor, when they bring in a backbone, they form a donor acceptor interaction, also band gap get reduced, and that's how we push this performance to very high. In this case, it can go up to 3.1, which is a very high charge carrier mobility. So these are our patented slide, and that's been now already licensed to the US company, and really glad and honored to say that these materials has been kind of utilized in a commercial application. We are getting some benefit out of it. Some of the kind of the polymers are listed here. We publish a number of papers using these polymers, and we believe that using these polymers we can print the devices on flexible plastic for future electronics. So we just recently also published a very high impact factor journal, Chemical Society. We have the impact factor close to now 54. So that's like kind of the how the sensor technology is useful for this transistor, and this is a kind of we can utilize it. That one of my PhD student, Pian Liu from China, he has made one of the new building block called as a naphthalene. He put up the extended naphthalene as a kind of a flanking group to depict molecules, same like Ferrari red color. And these are the kind of synthesis scheme looking at the naphthalene versus thiophene and then the furan it enhances the high thermal stability. So this was the dye first time reported in the world, which is a new kind of a sibling or family member of this DPP family. And interestingly, these dyes, when we took up the solution, they look the same color, orange color, but in a solid state, you see the appearance changes. And we kind of got a little bit confused. What's going on? In solution, we can see the same kind of a emission color, but in solid state, they are different. It means they have a bit of different packing. And then the packing really depends on what alkyl group we are putting. In this case, we put up a C10, which is we call as a decyl. Then we put a dodecyl, C12, and then we can put a hexyl decyl, C8 and C16, which is a branch alkyl chain, whereas these two are the straight alkyl chain. And upon taking this material, this is just a simple small molecule, not even polymer. Earlier, I showed most of the examples. They are all of the polymer semiconductor. Just consider this as a small monomer or small molecule, we still got an impressive mobility of 0.1. And this is like optical micrographs and all that. And we got a cover picture in the journal. Since it was a new dye we invented, it got journal has highlighted on the cover picture. So upon looking the solid state appearance changes, Kuyanlu and myself, we decided, can we shorten the alkyl chain from C10 to C8 to C6 and C8? We got these wonderful compounds, and we can see that they can grow the nice crystals. Those crystals are nicely illuminating under UV lamp. Upon utilizing this material as a thin film, we got a transistor. In a thin film transistor, we get a mobility of 0.05 for a small molecule, still very impressive. But using this nice kind of a single crystal between putting source and drain, you can see on my right hand side image, these are all of the fibers or kind of the single crystals. They are kind of put it between source and drain. So in inset image, you can see the yellow colors are nothing but the gold, and in between gold, these organic semiconductor thin crystals or crystalline kind of the single crystals are sitting between, and that's how the mobility has been gone up to 0.1, which is very impressive for small molecule. And why we decided these two molecules behave differently. ODPPN shows the better performance than the HDPPN. ODPPN is nothing but the octyl DPPN. HDPPN is a hexyl DPPN. So in case of ODPPN, we got a real single crystal data by X-ray diffractometry with Professor John Makmurthy. He is my colleague in QUT. And we can see ODPPN forms a wonderful pi-pi stacking, and that is the reason we get the better charge carrier mobility. Whereas in case of HDPPN, the charge stacking has been kind of disrupted, and that might be the reason why we got the low performance. So this slide, I would like to kind of highlight the Sudham, who is also in the audience. This is in collaboration with Sudham when he was working in Korea. We shipped this material to him to make a OLED device, and then using this material, using a TCT as a host and putting over this new dye, we made a OLED devices, particularly Sudham and the professor team has made these devices, and you see they form a wonderful yellow OLED small device, and we could reach really very high external quantum efficiency, which is a 4%. So whenever we see the quantum efficiency, means that once you're putting holes and electron, for example, you are putting 10 holes and 10 electrons, and all of the 10 gets recombined and form 10 photons, then it is called as 100% quantum efficiency, which is an internal quantum efficiency. But sometimes light gets lost because of the refractive index, what material we are using. So this external quantum efficiency value gets reduced. So far in OLED technology, when people are using OLED screen in LG and Samsung, their EQ values can reach up to 20, 25. And we are working on some of the material, they can go in a 2-digit, but they are super bright kind of OLED devices. Thanks to Sudham and all his team for making this. Got a nice kind of, the highlighted this article, this advanced electronic material. We didn't design another dye. I do have another PhD student from Iran. She has kind of put up some of this alkyl chain on a naphthalene DPP in a way that once we put a cyanide, as you know that cyanide are not good for human health, and you know that potassium cyanide kills the person. So if the cyanide present in a water, how we can detect? And this simple material, it changes the color. So if you bring the water which has a cyanide and you add this dye into that water, it changes from fluorescent to the non-fluorescent. So the cyanide anion present in that water molecule reacts with our molecule and then forms the ring closure, and the conjugation get disrupted, and it changes from fluorescent to the non-fluorescent. So this is called optical sensors or fluorophore sensing. This is kind of very interesting technology to detect some of the toxic chemicals present in a river, or even we are working on a pathogen detection like COVID and all that. Some of the molecule we are thinking to design to detect COVID early by changing the color. So there's a lot of interesting avenues there. So we do also work on a biosensing. So one of my another PhD student, Supri, she finished her PhD. She took up this naphthalene DPP. There is a technique called as electropolymerization. It means that you take the electrochemical cell, a working electrode, reference electrode, and then you do have a counter electrode. So once you switch the potential to this monomer solution, so you polymerize monomer basically by using electric field called as electropolymerization. So we make the DPPN type of polymer on directly on a glass, ITO-coated glass, which is a conducting substrate. We can take also ITO-coated flexible substrate, and then we get this flexible plastic sensors, which we put that in a DNA solution or RNA solution. It changes current, because the reason that the polymer, once we kind of sweep potential, they form a positively charged in the backbone. DNAs and RNAs, some of them are having a negative charges. So with a positive negative charge affinity, it changes the color and it changes the current. And this is what they are useful for biosensing technology. So we are working some of these materials or chips to identify some of the kind of cancer cells, where we can see the DNA RNA can be taken from cancer cells and can be detected with this electronic material. So this is again the combination of biology and electronics as a bioelectronics. And some of the detailed slides are given there due to time. I mean, they form a wonderful kind of a structure as shown in AFM. We also got a cover picture for this DNA molecule folded, looking at with our polymer, polymerized by electropolymerization. So another type of polymer Qian is making with the pyridine and selenophin type of polymer. These are the again. Selenophin is a very good kind of a donor, whereas the pyridine is electron withdrawing group. So once we put this flanking group in a DPP, either pyridine or might be some other N type, we make a more N type material. And there are very few organic semiconductor in the literature. They are kind of N type. N type means they have a better electron mobility characteristics. So using this PDDPY-SE, it is a short form, in collaboration with Jun Takeya in Japan, Tokyo University of Technology, we started a collaboration to determine the electron mobility. And indeed, in this case, we can reach up to mobility 2 point, which is a very impressive, and we got a very high impact journal paper, advanced functional material. You can see from gate voltage applying in a positive as well as a negative regime. It shows some of the ambipolar behavior with the P type as well as N type, but the N type charge carrier mobility is much more predominant, whereas the P-type charge carrier mobility is less. And this is simply because our backbone has a lot of N-type moieties like pyridine and this DPP, and again the pyridine, they are all N-type, and only selenophin is a donor. So we see slightly hold mobility, but more stronger electron mobility. Qian Liu, my PhD student, is like one of the terrific student. He has published almost 25 papers from my from PhD with me, and amazingly hardworking guy. He has made this another type of polymers where we kind of change the comonomers. Like we put up the constant comonomer as a fluorine substituted by thiopine, and instead of taking the DPP, in this case furan DPP and selenophin DPP and pyridine, we wanted to see what is the heteroatom of this on a charge carrier mobility. And this sulfur and fluorine, they have interaction. So we need to select this backbone or conjugated material in a way that they can interact better and they can form better peptide stacking. So these are some synthesis scheme. Most of our material, usually we go 5-6 step synthesis, we purify them. So purification and making them pure is really important to get the high performance. And when we make the devices, we get the silicon dioxide, which is a commercial available. We put it source and drain the polymer film on top of the silicon dioxide, and then OTMS you see here, which is nothing but it is a self-assembled mono layer, which we also called as a SAM layer. They kind of form a interspacing kind of a thin layer to make the polymer of high quality film, and interface traps can be avoided, and then you get a high performance. So using channel length and channel width with the capacitance of the gate, because your gate is a kind of a silicon dioxide is insulating material. So when you apply the potential, you accumulate the charges and you receive the potential, because it is a switch, it is not a conductor. And these are the kind of some of the energy levels, and then they give the like a performance of cold mobility 0.95. So in air and in vacuum, they change the performance. So most of the N-type material, once we expose them in air, they show more whole mobility. But once we expose them to the inert atmosphere, like in vacuum, they show the N-type. So this is a one-type polymer, which is in air show totally P-type, but once we take inside the glow box, which show the N-type. So this charge carrier polarity tuning, it happens because of the oxygen and moisture kind of, the exposure to the devices. We also made some of the other type of materials, which we called as electrochemical transistor, which has a lot of relevance in a bioelectronics to make the future implantable devices. Where the polar polymer chains are required. In this case, we have put ethylene glycol as a polar chain, and we enhance the transconductance. So similar like a pacemaker, we can have this type of devices can be implanted inside the body, and due to the polar nature and it not to be toxic with the body, we need to select the material in a way that it can form aqueous media, because our body is full of aqueous media, and that's what most of the testing usually requires, the polar type of materials. And we try to make this polar polymer to see the change in the conductance upon applying gate voltage. So this is just the initial kind of the work. We are still working more on that, and these are some of the other memory devices, and we got several cover pictures. I'll just quickly touch upon, might be another. So how long I do have a time, Avinaji? Another 15 minutes, 10 minutes?
Yes, Dr. Sanar.
Okay, how long I have? Another 10 minutes?
Yeah, 10 minutes here.
Okay, all good. So here are the kind of a solar cell technology where we utilize the perovskite kind of a solar cell, which is a very upcoming and exciting field. So perovskite solar cell can reach might be performance close to 25 or more than 25%. So these are the kind of some schematic. So once you shine a light on it, photons comes in. In perovskite layer, you form the exciton. Then exciton start dissociating across various layers. So ETL is an electron transporting layer, STL is a hole transporting layer, cathode and anode. Cathode is a positively charged, anode is a negatively charged. As the hole and electron, they kind of get separated, then we get the separate charges. So this whole process of conversion light to the electricity requires this transporting layer, STL and ETL. Without that, the charges don't have a kind of capability to transport to the cathode and anode, and we require these layers. So using whole transporting layer, we kind of develop a perovskite solar cell, and we also publish this kind of interfacial material, how they are useful for perovskite solar cell technology to push the efficiency higher in collaboration with some kind of Shenzhen University, China. So these are some of the development in our lab. We have developed the solar cell. If you see the solar technology, silicon is the first generation. Second generation is amorphous silicon and copper indium and cadmium telluride. Third generation is this perovskite organic disensitized, and these are the getting much more advanced solar cell to make a more and more cheaper and flexible and can be extended on a large area. So perovskite is really up there among all of the technology in third generation. Organic is a second. Now with organic we can also achieve 18%, but the perovskite, I believe that it may cross sometime soon to more than even 30%. There are also technology coming up where people take the silicon and then put up the perovskite and then pushing this performance further. So I took up one of this dye. This dye has been mainly utilized for cosmetic purpose, mainly for lipsticks and all that. So this is called the anthranthrone, which is a white orange 3 dye, which is a very interesting aromatic compound having a 2 bromine and some 2 ketonic group. We can do some interesting chemistry here by doing some sort of a Buchwald coupling. Amine group can be directly connected to the halogens. We can get this HTM, DPA, anti-DPA compound. We can do also Suzuki coupling. So boronic esters, when we attach to this bromine, this is called as a Suzuki coupling, and we can make this another 2 compound, AC, anti-AC, and then the triphenylamine, anti-triphenylamine. So triphenylamine is this end capping group, and this central part is the ANT. So please apology if I do have some of this funny name, but all chemists, we give these names because of the building block. TPA is a triphenylamine, ANT is an anthranthrone, similarly, the DPM is diphenylamine and then anthranthro. So upon utilizing this material, we got a kind of we first tested the charge carrier mobility, whole mobility of this new material. So our material is giving 2.6 into 10 raised to -4. If you compare our material with the classical material, most of the industries, even the academic institute all over in the world, they use this material called as a spiroamidite, which is a very expensive material. I think they have to spend maybe $2,000 per gram or maybe $1,000 per gram, depending on purity. And we have developed this material in our lab, which is just might be $60 per gram, and which is really, we filed a patent on it, and we here proved it. I mean, one of the compound which shows a very high kind of the stability. So you see this pyroamidite, which is a commercial material, it changes the performance very rapidly from 11.5%, so from 16% to the 15.2% here. Where our material remains kind of a stable from 11 point to 10.8. This is not that impressive. I mean, sorry, this is the case where we can see fresh device gives the 16%, but once you expose to the relative humidity 57, it goes to 2.3. So there is 85% degradation using the commercial material. But our newly developed material, it remains the performance only 10%. And this is coming because our material, once we spin coat the thin film and put a water droplet on it, water gets repelled, which is we called as a contact angle measurement. So they becomes more hydrophobic nature. And as you know that in a solar technology, if the water, moisture and all they come, they kill the charges and their performance degrades down. So this is one of the biggest challenge for perovskite solar cell to make a stable perovskite solar cell with a high efficiency. And we're trying to resolve this by this molecular engineering of this some new material. Among all of these three material, these two material particularly, one of the material has shown a performance close to 17%, which is a very high, because world record when we published this paper was that time 22, 23, and we were almost close to 18%. And these are the like synthetic cost $67 per gram. Actually, I think because of time, I won't play, but our journal has highlighted a wonderful video on it. I don't know whether you can listen it, and it has been nicely explained whole the technology. Might be because of time I may skip it. This work also got highlighted in Australian News Channel, 7 News Channel, which is Australia's national news channel, and it is like our energy minister who came and who kind of I will just play. Let us see if it gets played. So the energy minister came to our lab, and I was showing him this flexible solar cell, and I was explaining how they are useful. So this was the TV report came on a national channel, and the energy minister visited, and it has a lot of limelight. So these are the kind of other dyes which we made a new type of whole transporting material. It's called as a quinacridone. Using again the same quinacridone dye, we put the same end capping group, and we make this 3 polymer using the Suzuki coupling as well as Buchwald coupling, and using this nice colorful compounds, we got the energy levels. Usually we get energy levels by few techniques. One of the technique called as a photoelectron spectroscopy in air, or called as a PESA. So where you directly get the HOMO values. So these are the all HOMO values of this material. And these HOMO values are important because when we want to make a devices, we need to see whether holes are getting injected and electrons are getting injected, or they are getting separated. I mean, in case of OLED as well as in case of solar cell technology. So this energy diagram where these energy levels are really playing an important role. And upon using this, we could reach now this time efficiency 18%. So we are improving day by day. Like this has been kind of also demonstrated high performance. So some of our new material which we develop, they also are multifunctional material. So they are not only useful for solar cell, but the same material can be utilized for OLED technology. And here you can see the three material which we develop in our lab. We utilize it for the three different color devices, which are the OLED, where we see the blue color and slightly greenish and also the dark green. And then I see how they are looking wonderfully bright. We can reach up to the value of 18,600 candela per square meter, which is very high. And the same material we also utilize for perovskite solar cell. We could reach efficiency value close to 10%. So in perovskite, they haven't shown that high performance, but in OLED, they have shown a very high performance. So sometimes our material, they might have a multifunctionality aspect. So we have to make sure that how we can try to utilize them once we check out their optical properties, electronic properties, and all in-depth investigation. So some of other material in Japan, in collaboration with Japanese Okinawa Institute of Science and Technology, which is a nice, I had been to this Okinawa, wonderful place in Japan. It was earlier in it is still under the US Army, but they have a wonderful near to the beach lab is located. And I visited Yabing's lab, and then we made this collaboration and then made the solar cell using some of our developed material, and we could reach efficiency in this case like 16%. But these are again with like in that particular case, we use the dopant. In this case, these are the dopant-free devices. It means that whenever using the standard commercial material, when people use, they have to enhance the conductivity by adding some salt type of additives, and because of addition of salt, the whole material becomes highly vulnerable to the hygroscopic nature. So in this case, we haven't added any salt or dopant, and that's what the efficiency is still high, and that's what our perovskite solar cell devices show better performance and high stability. The last might be a couple of slides, and then I'll conclude my talk. So this is the wonderful work. It has also created a lot of buzz in Australia as well as internationally. So you will be surprised that how sometimes we have to think of out of box. You imagine as a human being, we do have a hair, and hairs has a they are having a protein called as a keratin, and keratin proteins are nothing but they are the polymer of the amino acids. So if you use this naturally occurred material, and if you go to the barber, you cut the hair and then barber throws out that hair. So we were asking, can we utilize this human hair waste for something meaningful? And it was my every day when I was walking from my house to the university, through a car or through, there was a barber shop. I used to go haircut. And one of my PhD student, Amandeep, who graduated from, who did his double masters from IIT Mumbai, and he did PhD with me in Australia. So we come up with a plan whether we can convert this human hair to some functional material. And once you take this human hair and then burn under inert atmosphere, we create some of the small dots, quantum material or nanomaterial called as a carbon dot. And this carbon dot, we can make them a luminescent by doing some surface science or surface chemistry. So we put up this hexadecylamine HDA with a C dot, and you can see there are two color bottle, the blue color, which is illuminating, which is with a linker. So when, as you know that whenever you burn the hair, sometime accidentally, there is a sulfur smell comes, like whenever hair burning, there is a sulfur smell comes because it has a disulfide bridge that gets cracked down upon hitting. So under the inert atmosphere, we convert this graphitic type of a carbon, and then using this surface science on a graphitic carbon at 240 degrees Celsius, we get this carbon dot solution, and we can get the photoluminescence quantum build up to 87%. And again, we can control the nice two-dimensional array of these carbon dots on a glass slides. And using this human hair-based carbon dot, we made the flexible device for display application. So here you can see on a glass slide, the nice illumination under UV lamp, but we also applied the electric potential here, figure A and B, where it shows a nice emission. The emitting nature of this carbon dot is as not that impressive as like might be OLED TV screen or something which you're looking. But the main message for this work we wanted to give to the community that waste has a lot of problems, and how we can resolve this waste problem by converting waste to the meaningful product. And these type of devices could be useful for small calculator displays, or they can be useful for a small bandage, or might be useful for small display, small devices and all that. So this is a really exciting story, and it has come in advanced material as one of the hot articles. And Amandeep took up this carbon dot, he dissolved it in a polymer called as a polyvinyl carbazole. We put up this carbon dot island 50 nanometer with PVK on a P dot PSS is another whole transporting layer on a glass ITO with a TPBI as an electron transporting layer and aluminum and lithium fluoride as a cathode. So this is the OLED device, and we get a photoluminescence and electroluminescence almost similar. So this has been kind of, barber. You can see the barber with whom I was standing in their barber shop. Then in our lab, some reporters, they came. It has been highlighted to the 17 websites worldwide, including Yahoo. And we are making some more. We now asking ourselves, these are the human hair. Like, can we check out might be the dog's hairs? Can we check might be depending on again the ethnicity? Like, Asian people have a black hair, whereas the foreigner people or Western people, they have might be white hair. And what is the protein structure? And there is a lot of underlying science. And we are trying to resolve few of these issues, and we are working on it. There are some lot of exciting upcoming research work on this line. With this, I'd like to thank to all of you for giving attention and listening my talk. I want to really thank all of my team members. I have done this lot of work in a collaboration with Japan, Singapore, Israel, Australia within national, as well as India, Taiwan, Korea. And like I'm expanding, I do have a vision to make multifunctional materials, multifunctional devices for future. Now I got some few projects on stretchable transistors for the future robots and all that. So I'm working on new material. Upon stretching, we can still retain the high performance charge carrier mobility, because sometimes some of the materials, once you run and all, they may change the performance. I'm really thankful to the Australian government, Australian Research Council. They give me a 1 million grant, which is around 5 crore when I started, my group in Australia when I moved from Singapore after 8 years. And I think before that, I was in Europe, in Germany for my PhD and Switzerland for my postdoc. All of these members, Dr. Thutrang, these are all of my PhD students. They have now become the doctor, and they are all are settled in a very well places. They are working, some of them in industry. Good to see that my alumni, my family, my group is expanding. Thanks to the device fabrication lab members and all of my other colleagues. I think with this, I'll just wanted to stop here. I'm happy to take the questions. And sorry if I was a little bit in rush, because there's a lot of slides to show. Still, I couldn't get time to other work, but might be some other opportunity I may explore, give some other type of talk. But this was covering some of the important highlights in a sensing area, as well as from display area, as well as from transistor area. Thank you so much.
Thank you. Thank you, Dr. Sunar. Now the session is open for questions. So the participant, whoever having their queries, for 3 minutes only. Any one of you, if you have questions? I think now there is no questions. So I thank you.
I think my talk was a bit clear, or people are shy.
Dr. Professor Sonar, really your talk was very, very interesting talk. And within a limited time, you have touched all the aspect of material science, because the present age, the age of functional materials, nanostructuring, and miniaturization of electronics, optoelectronics. And I have listened the first talk in which within a very small time, I could see all these different aspects. And I'm surprised at how could you manage different fields of the material science in a single lab. Really, your talk was very, very nice, very informative, and I'm sure the students and the researchers who are attending the conference and who are attending the conference through live streaming, they will definitely benefited from your talk. And if they will have any query, they will contact you through your email. Thank you very much, Prashantji. Thank you very much.
Thank you so much, Avinashji, and thanks all of the audience, as well as Dr. Rajendra and all of the Uttamrao College staff members for inviting me. It's my pleasure, and I'm happy to provide any support further for our rural area to bring the more students in the research line. And feel free to contact me, any students, anytime. You just Google my name. Happy to help you guys. Okay, take care. All the best. Enjoy the remaining conference.
Thank you.
Agrawalji, 1 minute. he is waiting for now Nobel Prize because he
Ah,
has now going to
really,
publish in Nature
we,
Journal.
we wish to see him getting Nobel
Okay,
Prize.
okay.
I think if I mean someone has told that if you want to kill the kind of a goat, you have to aim killing the tiger. If the Dr. Rajendra is saying that I want to achieve the Nobel Prize, at least I can get Australia's best highest national award or something. So I should aim definitely high. And I think for all of the students as well, I want to give the message that not failure but low aim is a crime. So just make your aim very high. And we never know, one day you will achieve it. So just keep determination and hard work, you will be there. Thank you. I'll just stop the sharing and then, yeah.
So Dr. Sheikh.
Okay, sir. Thank you very much, sir. It was such a thought-provoking, what can we say, thought-provoking plenary session. And thank you very much, Dr. Avinash Agarwal, sir, for chairing the plenary session 1. Now, it is time to begin our session 2, plenary session 2. It's an invited talk. I would like to invite Professor Dr. Gunwant Sonane from Parola College, Jalgaon, to chair the session. And we have the key speaker, Professor Dr. Mahavir Singh, Dean, Faculty of Physical Sciences, Himachal Pradesh University, Shimla, Himachal Pradesh. Over to Professor Gunwant Sonane, Parola College.
Thank you, sir. I am audible?
Yes, you are.
Yeah, thank you, sir. Good morning, sir. Good morning, friends. Good morning, one and all. I welcome you in this plenary session 2nd. First of all, I would like to congratulate Principal Dr. Rajesh Aide, sir, Uttamrao Patil Arts and Science College, Convener Dr. Rajendra Airao, sir, and all other organizing team for organizing such a theme-based conference and providing an opportunity to listen and interact with the scientists, researchers in the field of advanced material science. I welcome you all in the plenary session 2nd. The today's speaker of our session is Professor Mahavir Singh, sir. It gives me an immense pleasure to welcome you, sir. I am very happy to introduce Professor Mahavir Singh, sir. Sir is presently working as a professor and Dean of Physical Sciences, Himachal Pradesh University. Sir is a state stopper during his BSc. He did his PhD from IIT Delhi. On his credit, 250 research publications from international and national repute. Under his able guidance, 23 students did their PhD, 40 students did their MPhil. His citation is near about 3,500. His research areas is fabrication and characterization of ferroelectric, ferromagnetic, multiferro, PMS, and magnetic nanomaterials. He is among the top 2% of the world scientists as per the Stanford University survey. He is also the member of Commonwealth Fellow of UK during 2006-2007. He is visiting professor of Engineering University Brest in France. He is ex-vice chancellor of IES University Badi, Himachal Pradesh during 2015 to 2018. He is also ex-dean of engineering faculty of Himachal Pradesh University. So we have such an eminent speaker today with us. I would like to welcome you, sir. He is going to deliver his invited talk on magnetic nanoparticles for health communication, storage, and environment sectors. So welcome you, sir, and over to Professor Mahavir Singh, sir.
Okay, thank you, dear. So first of all, I am thankful to Uttamrao Patil Arts and Science College, Dhule, Maharashtra, for giving me the opportunity to participate in the international conference based on advances in material science, applied sciences, and engineering. First of all, thanks to Professor Rajendra for giving me the opportunity, and all organizing committee and principal of this college And I want to mention, I was discussing yesterday, I was in Delhi in some UGC assignment. So I traveled a whole night from Delhi to Shimla, and I reached here 3 a.m. As it was my promise. So, basically, Rajendra was worried, but I told him that don't worry, I will be in time to present my message in the form of a plenary talk to the delegates on this platform, this virtual international conference. So basically, I have active collaboration with Maharashtra people. I am collaborating with Maharashtra, whether it is Pune University or this Aurangabad, Nanded. I have so many collaborators in Maharashtra. So I can say after Himachal Pradesh, my second home is in Maharashtra. So I feel happy when I am, anytime in academic assignment Maharashtra, I feel happy that I am in my home. So with these words, as previous plenary speaker, Professor Prashant mentioned beautifully about the role of polymer in various applications, whether it is in solar technology, in sensor technology, and other optical technology. And I am going to discuss the magnetic nanoparticle. So the magnetic nanoparticle in health, environment, data storage, and communication sector. Dear friends, in the present time, world is facing with a lot of problem with COVID-19, and I can visualize that Maharashtra is the most affected state due to this pandemic. So basically, these magnetic nanoparticles are very, very important for the detection of COVID-19 virus and the treatment. So basically, the beauty of these magnetic nanoparticle is that they are safe, they are eco-friendly, and they are biodegradable. That is the beauty. As you know, when we go from bulk level to nano level, there is some kind of toxicity. Dear friend, there is kind of toxicity which we feel at nano level. But the positive part of these magnetic nanoparticles are they are safe, eco-friendly, and biodegradable. So there is no concern about pollution or toxicity issue in magnetic nanoparticle. That is why they are highly useful in health sector, especially for the treatment of cancer, for the treatment of targeted drug delivery, and other areas in health sector, even in MRI also. And data storage is another sector, as I think you must be aware of that in the present time in computer technology, big data and artificial intelligence are the new future in computer science. And even surface engineering, that is also very, very important in engineering. So the magnetic nanotechnology or magnetic nanoparticle will play the very, very important role. As Professor Prashant mentioned about the use of polymer, so I want to also mention here with the composite of polymer and magnetic nanoparticle and even graphene. So future, next 50-year future is about three big material. One is magnetic nanoparticle, another is suitable polymer, then another is graphene. So this is, I think these three materials, their composite, their smart material will play the very, very important role in various kinds of technology to come in future time. So basically, as you know, current issue in nanotechnology, whether it is toxicity, electromagnetic radiation, radiation is also very, very important issue. Then clean water. I think I have a lot of interaction with Maharashtra people. You are also facing the problem of clean water. It is everywhere. Even I am sitting extreme north in Shimla. We are also facing the kind of how we can treat the water because of mixing of bacteria or other pollutant. So clean water for drinkable is a real challenge at the present time. Then obviously health, data storage, communication. So I have active collaboration with French people, communication at ultra high frequency. As you know, Government of India has purchased a Rafale fighter plane. So I think in that in those fighter plane, these communication network is so active, so strong that this is also another area where we can use these magnetic nanoparticle for communication sector. So bright future of magnetic nanotechnology, as I mentioned, that there is lot of concern with other kinds of nanomaterial. There some people say about the negative part of nanomaterial, that there may be pollution, there may be toxicity, there may be even environment issue, then cost, then synthesis route. But the beauty of magnetic nanoparticle is they are non-toxic, they are pollution free, they are biodegradable. Moreover, they are stable. This is very, very important. They are stable, and we can easily synthesize it. Dear friends, and that was the era during my PhD in IIT Delhi. We used to cook these magnetic material at 2000 degrees Celsius. But today we can synthesize these magnetic nanoparticle even at 100 degrees. So you can synthesize even at college level, even at home environment. So it is easy, and more important, these magnetic nanoparticle cost is also less. So that is the beauty of these magnetic nanoparticles. And this is the bright future of magnetic nanoparticles. They are very, very useful, whether this is bioseparation, biosensor, molecular imaging, catalysis, and information storage. You must have heard about spintronics. Dear friends, I think instead of talking about electronics, people are talking about spintronics. So I think spintronics is the smaller part of electronics. So all the circuit in the present time are not coming in the form of electronics, they are coming in the form of spintronics. So spintronics means instead of electronic, chip is based upon spin. So spin has both advantage. It has charge as well as it has magnetic moment with itself. So spintronics is faster to act, and there is no loss of heat loss. So that is the beauty. Then sensor technology, in sensor technology, whether we talk about smart home, smart city, so magnetic nanoparticle will play the important role. Then molecular imaging. I think you must have gone through the MRI. So in MRI, pardon? Yes. Okay. So basically in MRI, we can use these magnetic nanoparticles. So that this is the future of, bright future of these magnetic nanoparticles. As I mentioned, I am again quoting for young researcher. At the center, you have magnetic nanoparticle. Then it is coated with suitable polymer. Then it is coated with graphene or graphene oxide. So that is the bright future for using this anywhere in the, whether it is in electrical sector, magnetic sector, optical sector, mechanical sector, or even any kinds of computer technology sectors. So magnetic nanoparticle, we all are aware of various kinds of magnetic nanoparticle. Dear friends, magnetic nanoparticle are driven from the iron oxide nanoparticle. So at the center, it is iron oxide. Then it is further enhanced with suitable dopant, whether it is from various kinds of, combination of transition metal or rare earth or suitable kinds of dopant. So again, just see the beauty of nature. Fish, the skin of fish is full of magnetic nanoparticle. जो मछली की जो स्किन है, it is full of magnetic nanoparticle. तभी तो ये 1000 किलोमीटर ट्रेवल करके मतलब 1000 किलोमीटर का ट्रेवल करके इसको कैसे पता रहता है कि मुझे कहां से कहां जाना. That is the beauty. Fish has natural navigation system inbuilt. So nature has inbuilt navigation system on the skin of fish. So that is the beauty, and that is why fish is very positive for health point of view because of these magnetic nanoparticle. So as I mentioned, because of quantum size effect and large surface area, magnetic nanoparticle are very, very important. Dear friends, you must have heard when we go from bulk to nano level, the surface to volume ratio is very high. So at nano level, surface to volume ratio is very high. That is why magnetic nanoparticles are unique, because magnetic nanoparticle surface to area ratio is very, very large. That is why it is exceptionally different than the other counterpart. So that is the beauty of these magnetic nanoparticle. And another super paramagnetic character. Because of this super paramagnetic character, it is used in health sector for the treatment of cancer and targeted readily and in implant infection, etc. for the tissue growth. So basically, because of this is physical character. Super paramagnetism is nothing. It is the advanced form of paramagnetism. Super para means in the absence of magnetic field, there is no magnetization. But once even there is fraction of small impurity of magnetism, it is detected by these material. That is why we call it super para. It is single domain operated system. Even it is beyond that. It is basically even beyond that single domain. So roughly it is single domain system. So it's not multi-domain. Multi-domains are available at bulk level, but single domain is available at nano level. So basically, if we want to use these magnetic nanoparticle in any kind of health application, we have to achieve, dear friends, super paramagnetism. Then second application is in communication. We can use these magnetic nanoparticle in communication. So in communication, we work on permittivity and permeability. I think we are aware from +2 level, the permittivity and permeability. Permittivity is nothing. It is electric medium for the behavior of electric medium for the material. And permeability is nothing. It is the behavior of magnetic medium for the material. So we control the permittivity and permeability, both real and imaginary part. If we want to build up any kinds of antenna for any application, in a different application, a different region of frequency, we have to control the real and imaginary part of permittivity and permeability. So it's not big rocket science. I think we are aware of this permittivity and permeability. The only thing is you have to control both real and imaginary part. Actually, in real science, what happened when we increase the frequency, our imaginary part increases. So the material become lossy. So that is why we have to control the imaginary part. Minimum level, close to zero. When I'm saying close to zero, it means it should be 0.01, 0.02, or 0.03. So that should be the prerequisite requirement. Then another is storage sector. As I think storage sector is very, very important. Data storage, big data. So you can observe in pen drive. So what is the beauty of pen drive? It can store large amount of data per centimeter square. So for storage, what we need saturation magnetization. I think this is also, we are aware of this parameter at +2 level. Schooling in high secondary schooling, we are aware of the magnetization. So basically, if we want to use this for the storage kind of application of data storage or magnetic data or electric data, we have to control the saturation magnetization. Then environment is also big. I think in Delhi, we all are aware of, in Delhi, especially in winter, there is a lot of issue related with environment. So environment means air, water, and soil. So basically, pollution in air, pollution in water, and pollution in soil contaminate our environment. So through corrosivity of the magnetic nanoparticle, we can control the pollutant of the environment. So I have used Rohtang. I think you must be aware of Manali, Kullu Manali, Rohtang Pass, where we have studied the kind of pollutant available in environment. So we control through corrosivity. We control the aerosol quality and pollutant level. So basically, these are the 4 applications of these magnetic nanoparticle. As I mentioned, these are the basic parameter: permeability, saturation, corrosivity, and electromagnetic medium and loss. So all these parameters are shape, surface, and size dependent. As I mentioned, when we go from bulk level to nano level, there is change in shape, there is change in surface, and there is change in size. So basically, dear friends, it is the interplay of shape, surface, and size. Through these 3 control, we can control the beautiful applications of these magnetic nanoparticles. Then Magnetic system is of two types. One is soft and other is hard. Soft means small corrosivity. Hard means large corrosivity. So we can distinguish magnetic system also. One is soft and other is hard. As in mechanics, if stress strain, if it is large, it is plastic or hard system or soft system. Similarly, we can distinguish it in magnetic system. So basically, just see the introduction, size, shape, and this is multi-domain. This is interesting. This is multi-domain. We have studied this at +2 level physics. Domain theory जो हम पढ़ते हैं, multi-domain. This is single domain. So this is the super paramagnetism. So we have to achieve this state. If we want to use any kind of magnetic nanoparticle, we have to achieve this state. And for this state, there is two energy. One is anisotropy energy and other is thermal energy. So basically, it is basically interplay of two energy. One is anisotropy energy and other is thermal energy. So if thermal energy is greater than anisotropy energy, then it is super paramagnetic state. That is the beauty, and it is so powerful sensor, so sensitive for the detection of even minute magnetic field. Can you believe it can sense our susceptibility of blood? Our blood is also magnetic, but susceptibility of blood is so small that we can't detect through other technique. But if our magnetic system is of super paramagnetic in character, it can sense the susceptibility of blood. So what is the beauty of that? That I think for diagnostic purpose, if we can sense the susceptibility of blood, that will be very easy for the diagnostic purpose for the treatment of any kind of disease. As COVID-19 I mentioned, so we also hit there for the susceptibility. So it is easy for RT-PCR test. आपने सुना होगा RT-PCR test, उसमें बहुत सारे error भी आते हैं. But through this magnetic, through this technology, it is 100% accurate and it can detect 100% accuracy. But the problem is, because of clinical trials and various health protocol, still there it is in clinical trial. There are few reports in Nature. So basically, next in future time there will be strong sensor which can sense the this virus effectively and with 100% accuracy. So just see, this is multi-domain and this is single domain and this is SPM. So dear friends, अगर आपको ये magnetic nanoparticle, if you want to use in health sector, you have to achieve here. So this is ordinary world. You can say this is ordinary world, and this is the nano world of magnetic, that is SPM. So basically, these are the surface and symmetry. So because of this symmetry and surface effect, these magnetic nanoparticles are unique, and we can achieve this SPM state. So they just see here, all the magnetic nanoparticle, there is no agglomeration. They are stable. Their shape is some spherical. There is clear defined shape. Otherwise, dear friends, we can't otherwise use in health sector. अगर आपको इसको drug के तौर पर use करना है, our magnetic nanoparticle should be, their shape should be uniform. There should not be any kind of agglomeration. So that is prerequisite requirement, and I think magnetic nanoparticle fulfill all the criteria. Then I will not touch this. This is a Mosbor, another indication. We can authenticate that whether our system is SPM or not. So this is ordinary magnetic material. This is nanomagnetic material. So through Mosbor, you can also sense that what is the change in magnetic behavior of nanomagnetic system. So this is exact SPM. SPM means whose corrosivity is 0. Just see here, its corrosivity is 0. So that we have to achieve. So ये जो बड़ा hysteresis होता है, we have to reduce this like this. Then we can use in health sector. Just see, this is SPM, super paramagnetic character, through Mosbor spectroscopy. So the iron oxide, and again this is SPM, whose corrosivity is close to 0. Again, this is SPM. So we have used these iron-based nanoparticle for the treatment of cancer in hyperthermia application. Then these are the routes I think you all are aware of. We can synthesize these magnetic nanoparticle with all these techniques. I have fabricated thousands of magnetic nanoparticle with all the applied techniques. But yes, this microemulsion is the very powerful technique, where we use the surfactant for the control of size of the nanoparticle. So these are the few methods where we can cook these magnetic. These are the XRD. Again, their shape is controlled. Then this is ZFC and FC. Another test for whether our magnetic nanoparticle is in SPM range or not, that can be sensed from the blocking temperature of ZFC and FC. So this is some calculation of susceptibility data, AC susceptibility. Then we have also fabricated nanoparticle with gold-plated nanoparticle. It is their shape and size. This is SPM. SPM, as I mentioned, if we want to use in a particular application, it should be in the SPM state. This is again Mosbor, again SPM at different temperature. That is prerequisite requirement. Then this is the microemulsion, through which we have synthesized different kinds of controlled magnetic nanoparticle. Again, there is no agglomeration. All particles are independent, stable, and we can use for health sector in targeted drug delivery and treatment of cancer. And again, we did some theoretical calculation of these nanoparticle. We calculate the distribution function, theoretical distribution function. Again, we apply in-field data also. We calculate, just see, this red is for bulk and this black is for nano. I think you must have gone through the X-ray. X-ray में जब आप देखते हैं कि broad peak का मतलब है it is nano, narrow peak का मतलब it is a bulk. तो broad क्यों होती है nano level पर? It is because of the surface disorder. Dear friends, when we go from bulk to nano, surface disorder हो जाता है. As I mentioned, surface becomes prominent at nano level. So because of surface disorder, there is broadening. So Mosbor also authenticate. This is Mosbor data distribution function. This black, this black and this red. So this is in-field Mosbor data. Again, but I want to mention one thing here. We calculate, our group is the first in the world who calculate the surface disorder. As I mentioned, when we go from bulk to nano, this is core, and this is surface. So at surface, there is disorder. So we calculate through Mosbor spectroscopy in-field data with Indore, IUAC Indore, and we also calculate through SQUID data. So there was matching between magnetic parameter came from SQUID and magnetic parameter we achieved through Mosbor. So there was matching and we calculate the disorder. कि कितना disorder है surface पर. If we can calculate that, then I think we can control the disorder at nano level. So this is again the blocking temperature. We calculate the theoretically also the thickness of the magnetic nanoparticle. So there was we calculate Langevin function. So we calculate the Langevin function and we try to calculate the thickness of the surface thickness of disorder. It was very well matching with the in-field Mosbor data. So it is very well fitted with the theoretically and experimentally. Again, there is matching between experimental and theoretical. And we also apply the various models for the AC susceptibility of real and imaginary part. So we apply the VF law for glass transition temperature. So it was very well fitted with this model, and through this law it was very well fitted. So that means in our magnetic system at nano level, Vogel-Faucher law is suitable to explain the transition. So we apply this for the treatment of cancer, for hyperthermia technique. We apply this for the cancer. Then these are the our complex magnetic nano. We have written few recent works on these magnetic nanoparticles. Then communication, we use the Dr. Raj. Sir, how much time I have?
Sir, 10 minutes more, please.
Okay. So another, so it was the first word was health. Now second is major challenge in communication. As a communication, we all know we without mobile we can't even think about even minutes without mobile. So communication is very important area. So in communication, magnetic material is the leading player. Without magnetism, you can't think the communication. So it is also very important. So use of nano antenna and gigahertz ranges is very important. And for that, hard magnetic material is the king. So basically, it is also a future material in communication sector. So we control the permittivity and permeability through network analyzer, and we use the Maxwell equation. It's not big rocket science. It is all fundamental Maxwell equation where we use this and we calculate the electric and magnetic parameter. And in different frequency region, I think we all are aware of this ground wave, diffraction, reflection, free space. Similarly, we use for different frequency, different kinds of setup for the antenna application. So we calculate this impedance. So basically through this, we can measure this permeability tensor. Dear friend, we measure here permeability tensor. I am saying permeability tensor. Experimentally, measurement of tensor is very difficult task. So, but through this network analyzer, the beauty of today's advancement in computer science, we can calculate experimentally this permeability tensor. It consists of every information of antenna. If we can measure experimentally this permeability tensor, it consists of every information of antenna for different frequency region. That is the beauty. But first step is how we can calculate this permeability tensor. If we are successfully for that, then we can design various kinds of waveguide or different antenna for different frequency region. So I am working on this area in the microwave right from 1989 when I was in IIT Delhi. But at that time I was used to for this antenna bulk magnetic system. But today we are collaborating with the different universities. Now we are using, instead of bulk, we are using nano magnetic system for ultra high frequency region. So for this purpose, our objective was to control the loss. Loss control is very important at ultra high frequency. Loss is major problem in physics. Electric loss, magnetic loss, hysteresis loss. So loss is very important. So similarly, if you want to use antenna in ultra high frequency, control of loss is major tough task before us. But through different kinds of engineering and ability of research innovation, we can control both electric and magnetic losses. So we have fabricated various magnetic nano antenna application where we have controlled the imaginary part and improved the real part. Again, we have synthesized various magnetic nano for communication. Now, third is environment issue. Dear friends, as I mentioned, magnetic nanoparticle for environmental purposes such as contaminant removal, remediation, and water treatment. So for this, I think this is I can say major research area in the present time for young researcher. If you want to, if anybody is working on the environment, I think they can use magnetic nanoparticle, polymer, suitable polymer, and graphene with suitable, co-doping, some composite or smart material that can be very useful for the treatment of pollutant in environment. So another is, drinkable water. This is also another area, I think. Dear friends, I want to convey through this international conference, so especially to Maharashtra people. Basically, water problem is not the problem of Maharashtra. It is everywhere in India. I think there is a report that next 10 years, major city will strive of safe drinkable water. Even in Shimla, we are facing this kind of problem. And the unfortunate part is we have left with 2.8% fresh water. That is the hard truth. So drinkable water is a real challenge before the researcher. So through magnetic nanoparticle, we can purify the water especially bacteria removal. We can remove the bacteria through this magnetic nanoparticle filter. Sometime, even college teacher also point out that we can use, UV or RO system. That is right. But the problem is common people. If common people want to use safe drinking water in the public tap, how he can get that pure water? So through this magnetic nanoparticle technology, we can purify the bulk water. पूरा टैंक अगर है, जो कम्युनिटी टैंक है, जहां पर पूरे शहर का पानी होता है, उस पूरे टैंक को इस टेक्नोलॉजी से साफ किया जा सकता है। इस टेक्नोलॉजी में घर में लगाने की जरूरत नहीं है। इसको आप जो शहर के लिए पूरा टैंक की सप्लाई है पानी की, whole water can be purified through this magnetic nanoparticle. No doubt, some IIT people, some BHU people, even some European or American people, they are using silver nanoparticle. But dear friends, silver is very costly. As I mentioned, magnetic nanoparticles are the cheapest product. Iron तो सबसे सस्ता है, तो iron से ये सब कुछ बन रहा है. So I think we all can work in this area, and there are beautiful applications. Whether it is health, communication, storage, or this purification, water purification. So last point of my talk is data storage. So data storage is also very, very important. For this, we have to improve the saturation magnetization. As I mentioned, अगर आप saturation magnetization को increase करते हैं, तो you can increase the storage power of data. जो क्वांटम कंप्यूटिंग की भी आज की डेट में बात हो रही है. So that is nothing, that is basically spin based, spintronics, as I mentioned, spintronics based technology. वो spintronics based क्या है? That is towards the big data. So this is basically some key issue. Key issue is, at the extreme we have ferroelectric, on the right we have a ferromagnetic. So how we can compromise both? Coupling, दोनों के बीच कैसे coupling करें, जिसको हम multiferroic कहते हैं. This is another material. Then it is spintronics, means electronics, optics and magnetism. इसको unify करना है. देखिए, for young researcher, my message is, if you want to use any kind of research, you have to think about smart material. Smart material means you have to, unify different kinds of technique, whether optics, electronics, magnetism, that consist of a spintronics. Then, as I mentioned, when we go from surface bulk to nano, there is disorder at the surface. There is disorder at the surface. इसको आप spiritualism भी देख सकते हैं. जब आप meditation करते हैं, तो you find lot of problem because of various kinds of stresses in our mind, in our body, in our blood. So similarly in material also, if you go from bulk level to nano level, you have to encounter with the surface. तो surface को समझना बहुत इंपॉर्टेंट है. इसीलिए मैंने आपको इनिशियल रिमार्क्स में कहा, आने वाले समय में सरफेस इंजीनियरिंग विल प्ले द वेरी वेरी इंपॉर्टेंट रोल. आई एम सेइंग सरफेस इंजीनियरिंग. When I say surface engineering, it may be civil, it may be mechanical, it may be computer, it may be electric, it will be surface engineering. That is my message. So future physics about magnetism, it is spin phase, graphene polymer coated with magnetic nanoparticle, I have already mentioned, and future composite hybrid material. A future hai. This is the future for material science. Important thing, it is eco-friendly, biodegradable and compatible. That is the big message. So the use of magnetic nanoparticle means we maintain the environment, we maintain the ecology. So basically there is no threat. Otherwise, there is a lot of talk of pollution by using of nanoparticle. But magnetic nanoparticle, there is no such concern. So this graphene, the beauty of graphene is it is strongest, it is lightest graphene, it is flexible. Just see think about in terms of physics. It is strongest, it is lightest. कैसे हो सकता है? ये हमारी सोच को थोड़ा सा अलग कर देता है. जो स्ट्रॉन्गेस्ट है वो लाइटेस्ट कैसे होगा? फ्लेक्सिबल भी है, जैसे मर्जी मोड़ो आप, टूटेगी नहीं. दैट इज द ब्यूटी ऑफ ग्राफीन. देन ट्रांसपेरेंट है, तो फिजिक्स देखिए कैसे चेंज हो रही है, और कंडक्टिव है और थर्मल कंडक्टिव है. तो ये ग्राफीन इज वंडर मटेरियल. और ग्राफीन है क्या है? इट इज बाय प्रोडक्ट ऑफ कार्बन. ऑर्डिनरी आप इसको कार्बन कह रहे हैं, नैनो पर उसको ग्राफीन कह रहे हैं। ग्राफीन बेसिकली क्या है? लेड पेंसिल का पाउडर लीजिए, सेलो टेप से करिए, दैट इज रफ फॉर्म ऑफ ग्राफीन. So with these words, I conclude my talk here. This is the future, as I mentioned, about the smart material in coming times to come. So with these words, thank you very much.
Thank you, sir. Thank you very much for your informative talk on magnetic nanomaterials and their application in various fields. Dear friends, sir enlightened us about the bright future of the magnetic nanomaterials, magnetic nanotechnology, application of magnetic nanomaterials in various sectors like health, communication, storage, and environment. Sir explain the things with very fundamental concepts and their application for the materials. So starting from fundamentals, so sir give us message to think about the application level also. Sir also explained different application, essential conditions and requirements to prepare different magnetic nanomaterials and super paramagnetism to show different properties and applications. Sir also explained the applications of mass bar spectroscopy in calculation of surface disorder in nanomaterials and how surface technology is important in future one. Sir also explained various applications of magnetic nanomaterials in cancer, hyperthermia, antenna in communication, magnetic nanomaterials for removal of contaminants from pure water, and also in data storage. So thank you, sir. Thank you very much for your informative talk over here. Now
Welcome,
session
welcome,
is
sir, welcome.
Yeah, session is open for discussion. If any researcher has any query, please they may ask the question or doubt. I think no one has any question. If they have, they will contact you through email. So thank you, sir. Now I conclude the session. I am very much thankful to the organizing team member and convener of the conference, providing me an opportunity to chair the session. So thank you one and all. Over to Sheikh, sir.
Thank you very much, sir. It was really a thought-provoking session, and it was also a brainstorming session. Thank you, both of you, the chairman of this session, Dr. Gunwant Sonone, sir, and the keynote speaker, Professor Dr. Mahavir Singh, sir. Thanks a lot. Here I declare that the session 2, plenary session 2 is concluded. And now we have a small technical session, a guest talk, and its chairman is Dr. Sudham Chauhan, SGP College, Sakri. And the speaker of this session is Professor Dr. Neetu Chopra, Jalandhar, Punjab. I request Professor Dr. Sudham Chauhan, sir, to chair this session. And I request to start this session. Over to Professor Dr. Sudham Chauhan, sir.
Sir, please unmute yourself.
Thank you, sir. I will, due to the short period of time and limitation, so I will request to the professor to present his work. Please continue to present his work. Thank you.
Yes, a very good afternoon to all. Thanks to first of all, I would like to say my gratitude and thanks to the organizing committee of this international conference on advances in material, applied sciences and engineering, who has given me the platform to interact with such an intellectual and august gathering here. It's my proud privilege to be here through this online platform. I am fortunate to present my research findings before you all. As the time is very short, my talk is just for 10 minutes. So without wasting much more time, I would focus on my talk. Let me share my screen. I hope it is visible to everyone.
Yes, ma'am.
Okay, thank you. The topic of my talk is the effect of heat treatment on the spectroscopic and structural property of the rare earth doped telluride glasses. So it is a combination of telluride borate with the modified as a zinc oxide. So I hope we all are aware of glasses. So glass is the oldest man-made material, yet greatly affects the human life. We all know in today's world, wherever we see, we have a number of glasses, starting from the electric lamp to communication cables, from glass windows to wine bottles, from decorative material to variety of the chemical glassware. We have a variety of the everyday human requirements in form of glasses. So much of the glass science is developed on the basis of the major commercial uses of glass. So glass is used as an active as well as passive material in the latest laser systems. So there's always a quest for new materials. We all know our day-to-day research is based on the latest advances in the materials. So here we have advanced materials depending upon the structure as well as the functional. So we have glasses as well as glass nanoceramics. So my basic work is on the glasses and nanoparticles. It means within a crystalline material, within an amorphous materials, we have to create a crystalline material. It is a glass nanocomposites. If it come in the dimension of the nanoparticles, then we can term it as a glass ceramics, can be termed as a glass nanoceramics. So I start from a basics from a glasses. We all know glasses are the amorphous solids having no crystalline structure. It has a long range order, and the very important property, it's like a frozen liquids. So glass is a amorphous solid which is completely lacking the long range order. It has a short range, but exhibiting the region of glass transformation behavior. So that glass transformation behavior can be understood with the help of this curve, that whenever we have to change from the liquid to the solid, there are two cases, whether we get a solid in form of glass or in form of the crystals, depending on our cooling rate. So here is a variation of a specific volume of melt as a function temperature when being cooled at different rates. So if there's a fast quenching, then we will get the glass. For the slow case, we are getting the crystalline behavior. So there are various components on the basis of which we have a different type of the glasses. So first of all, I discuss the glass formers, which is in form of the silicas, phosphate, borate, or telluride. My basic work is on the telluride glasses. And there are some intermediates too that do not form the glass on their own, but help in the formation of the glasses. So here in my case, I am using the zinc in our research findings, and there are various modifiers as well as there are the dopants. So dopants play a very important role. And in the day-to-day research, we are having a rare earth glasses as a very good dopant because of the interesting application in the optics. And on the basis of the glasses, we have oxide glasses, chalcogenide glasses, halide glasses, and metallic glasses. On the basis of the former, whether we are using it as a borate, the form of the oxide, or in form of chalcogenide, or in form of halides or metallic. So different type of glasses have a different applications. So which type of application we need, we have to choose a former as well as dopant and the modifier on the basis of that. So glasses have a various application, and very important application in case of the glasses are basically used as a very good role in the laser systems, in the active as well as in the passive role. So now let's come to the other category, how glass ceramics are different from glasses. So glass ceramics are basically polycrystalline materials, which are produced from the basic glass by having a controlled crystallization. So, but glass ceramics have very important, very interesting properties. They are behaving like a glasses as well as ceramics. So it has a amorphous as well as the crystalline structure. So this is the beauty of the glass ceramics. And the crystallinity varies only between the 0.5 to 99.5%. And it is a controlled crystallization how we have to create a nucleus within the amorphous material. And that nucleus has a crystallization process. So let's see how these glass ceramics are different and why these are more important as compared to the parent glass. Because in case of the glass ceramics, we have a better thermal stability. It has a superior electrical insulation, high mechanical strength. Thermal expansion coefficient is very good. It has a very good, excellent optical properties. And we can have our desired property on the basis of the glass ceramics by having a controlled nucleation. So many biomaterials like dental implants are based on the glass nanoceramics. Even the ceramic tops are there, glass tops are there. Telescopic mirrors are made of the ceramic glasses. So for the having a proper applications, we have to choose a glass composition. Now, in case of my research findings, I am using the telluride glass as a glass format. Why telluride glasses? Because it has a very low Fresnel energy. It has a high linear and non-linear refractive index, high dielectric constant, and the important one is has a good corrosion resistance. And along with that, because telluride itself is difficult to create in form of glass, so we use a borate composition along with the telluride and zinc oxide as a glass modifier. Now, as I have earlier said, that dopants are very important. And rare earth are playing a very good role as a dopant. And here in my studies, I am having a erbium as a dopant as well as a dysprosium. No doubt, we did number of studies on the other dopants too, but here I am discussing only about these two dopants, how their behavior is important in case of glasses. Because rare earth has a very good cross-sectional area. And they are very good in the non-linear optics as well as in the laser systems. So erbium, what is the specialty in the erbium? Erbium has a strong green emission, whereas the dysprosium has a green as it is used for the white light emission. It is a current area because everything you are looking at the LEDs, we need white light LEDs instead of the fluorescent lamp which are yellow in color. So dysprosium is very good white light emitter, because it shows a very intense emission in case of the blue as well as yellow colors. Now let's have a research findings of the telluride borate with zinc modifier along with the dopant of dysprosium as a glass as well as a glass nanoceramics. So here is a thermal study that how the effect of temperature is there on the glasses. So along with the controlled temperature, we can create a glass. So here I have a composition of the telluride borate with a no dysprosium, with a 0.5% dysprosium, with a 1, 2, and 2.5%. So the greater delta T shows that there is a more stability of a glass. And here is the XRD studies of the glasses and glass ceramics. This black curve shows that there's a glass, that there's no curve in the XRD. But whenever I have converted the glass into a glass ceramics, there are number of the peaks which shows there are number of the crystals formation. And here is a very good studies of the FSM that shows that the nanoparticle size of these crystals is in the range of the 80 to 100 nanometers. So we can say these glass ceramics as a glass nanoceramics. So here are the studies of the Raman before the heat treatment and after the heat treatment. Before heat treatment, I mean to say that it is a glass, and after heat treatment, it's a glass ceramics. So before heat treatment, there are no curves, and the particular peak shows a particular structure formations. While in case of the glass nanoceramics, there are particular peaks, sharp peaks showing the different formation of the bonds within this. So here is a theory of the optical spectroscopy, that is absorption spectra of the glass and glass nanoceramics, by which we have a Zodofeld parameters. And then these Zodofeld parameters are very important in the case of the glass nanoceramics because the large deviation shows that the dopant dysprosium play a very important role in the crystallization of the nanocrystal particles. So here is a study of the optical properties of this, that the band gap of the system of the glasses and glass nanoceramics is different. There's a less band gap in case of the glass nanoceramics, while glasses of the same period atom shows a more band gap. And relative properties. Then the photoluminescence parameters that shows that in which range we are getting the emission. So in case of the dysprosium, the emission is in case of the green and blue bands, which shows a white light emission. So the emission wavelength is around 575 nanometers, and for different glasses and glass nanoceramics, we get a very colorful range of this, which shows this parameter shows that this nanoceramics are very close to our commercial LEDs. So these white light emitting glasses and the excitation of 383 gives a emission wavelength of 575. They are very good as a LEDs. And the decay analysis of the peer shows these glasses are very good in case of the laser systems as well as for the optical communications. So this decay parameter obviously decreases with the heat treatment. Now, if I take the other glasses, instead of dysprosium, if I do my studies with the erbium, then the results are very much interesting in this case too, because as the dysprosium is for the white light emission, this erbium is for the other parameters are very interesting. So in this case, we have a stability factor very high, and with the addition of the erbium, a number of bonds are replaced, telluride bonds are replaced by the erbium bonds. So here is an analysis of the glasses and glass ceramics. Glasses has again no peak, while the glass ceramic shows a very good peaks with a particular crystallization. And this FSM result shows these nanoparticles are of a size of 35 to 40. So here results are even better than the dysprosium in case of the nanoceramics. And here are the studies of the absorption spectra of the prepared and glasses and the glass nanoceramics in the UV region as well as in NI region. So in NI region, the emission spectra of the erbium dot glasses are excellent. And it shows the trend of that the different parameters are in the same sigma 2, it is always written in sigma 4 and sigma 6. In all the parameters for all the prepared glasses, the results are exactly matching. So it is the interesting case here, and how this erbium plays an important role in the telluride glasses. So here is a bonding structure of the telluride with the non-bridging oxygen as well as with the bridging oxygen. As we keep this dopant in the telluride, we have this bond structure to be changed from Q4 to Q3. So more bonds will be, new bonds will be formed, and the reduction in this causes a decrease in the bond energy, which gives a addition of the non-bridging oxygen. So all these are relative parameters for the how these such type of glasses as well as the glass nanoceramics can be used as in the optical communication for the optical devices like optical sensors, etc., because of their good relative properties. So in all these cases, the most important parameter is the low quantum efficiencies. And this parameter is only because of the small energy gap between these two levels. It is a H11/2 and F9/2. So this is the beauty of this erbium. And the excited states are lost in case of the multiphonal relaxation. And because of this, there are very less non-relative transitions. Because our main aim to have a good laser properties to reduce the non-relative transitions. And because of these parameters, there is a reduction in the non-relative transitions. And here is a peer characteristics of the erbium glasses, which shows that for the excitation of 380 nanometers, we have an emission at the 530 that belong to the green region. So this shows a visible emission spectra in the green region for the glass ceramics as well as for the glass nanoceramics. And decay parameters are exactly same as that of the dysprosium, and there is a decay decreases, so which is the interesting for the point of the laser applications. With this, I am here concluding my this relative parameters as well as, because relative parameters are exactly same as that of the dysprosium, and decay curves are exactly same, only with a small difference that here there, with the addition of the nanoparticles, there's a decrease in the chances of the non-relative decays. So that gives a very important property of the lifetime. And this is a best result of the erbium glasses. And this result is that there's an up conversion. Normally we have a down conversion in every case, because whenever we give the excitation at a, suppose at the 300, we get the emission at the beyond 300, maybe up to 400 or 500 or 700. But here in case of the erbium, there is an up conversion. If we are giving the wavelength emission at the 300 nanometers, we can get the emission at even below 300 nanometers. So this is the up conversion spectra of the erbium, which is an interesting case here. And here I am concluding my erbium results that XRD shows a very good results of the nanoparticles. Geoparameter shows that there is a quite changes in the structure because of the erbium glasses. And for the same rare earth concentration, if we are moving from the glass to glass nanoceramics, there is always an increase in the lifetime values. And this increase in the emission intensity is a very good result for the up conversion intensity after ceramization. No doubt, glasses are not giving us the up conversion. But if we are changing from glass to glass nanoceramics, we are getting the up conversion, so which is very interesting. And because of these interesting results, we can say that these are erbium doped glasses are very good medium for the lasing actions. So thanks to all. If I have not taken so much time, because I have tried to consume all these research findings within a 10 minutes time scheduled to me. Thanks a lot once again to the organizers.
Thank you, madam.
I end my talk by just giving a message that perfection is not attainable. If we chase perfection, we can achieve excellence. So we should keep on doing one or other thing in our coming times. So once again, thanks to all the members of the organizing committee who has given me a chance to share my findings with you all. Thanks.
Yeah, thank you, madam. I will request to audience, if they have any question, please, this session is open for question. Is there any question? Is anybody has any question? Madam, I do have one question. Since sure. This material is a phosphorescent materials, I guess. Yeah.
Yes. Of
so
course.
You dope with iridium and dysprosium. So what are the limitations for this material in order to convert or to realize that this material could be used in real LED? Because there are some LED technologies. They are using different materials, which are germanium based semiconductors, but that technology is very costly as compared to these materials. So what is your take on this point?
Yes, a very good question. Actually, basically there are so many LEDs on the basis of the germanium and other technologies. But if we use the LED on the basis of these rare earth classes, the one main drawback, no doubt, it is very good light emitting, because as the sir has told me about to give the negative point of my rare earth dot classes. So I am telling that these rare earth classes are somewhat costlier, because rare earth are not so abundant in the nature. So we have to collect it. So, but it shows a very good drastic changes whenever a very small amount, just a 0.5% of the total composition. If I'm taking just this much amount in my whole of a glass of telluride, it gives a drastic result. It completely changed the properties of the glasses. So only one negative is this, it's rarely abundant. That's why it's named as a rare earth. Otherwise, it's giving a drastic results.
Yeah. Okay. And one more question. As you showed that the materials is converted into ceramic after annealing, but you didn't say that what ambient you anneal that materials and what was the temperature? Is it more than 1000 degrees Celsius or less than 1000 degrees Celsius?
It's again because I have skipped this thing because of a scarcity of the time. Basically, whenever we have to convert a glass to a glass ceramics, then always we have to do the trials for different. First of all, we make a glass, then we will put it in at different temperatures. We have to give a trials. Suppose I have my glass is made at a temperature of 900 degrees Celsius. Then after a solid form, I will give it a heat treatment of 300 degrees. And then check the result, then do the XRD. Whether there is a ceramization, if it is not, then I will go for some other range. So this is by the trial, for the 4 or 5 trials, for a particular range, I will get the optimization. That for this, this is the optimized temperature for such type of glass. And it is always different for different compositions. So you have to go for the trials.
Okay. Yeah, because it is very sensitive to oxygen molecule. If I remember and if I understand a little bit that if the oxygen is if ceramic material is react with oxygen, then its efficiency, phosphorescence efficiency reduce significantly. So that is one tricky point in this case.
No, sir. Basically, it depends on the glass composition. If you are using a alkali boarded glasses, then it gets easily readily oxidized. So it is difficult to get a ceramic. Okay. But in case of a telluride and along with the board composition, it's quite stable. It doesn't get readily oxidized.
Okay. Yeah. So that's the beauty then. It is really good material as compared to other available materials in the market. Now, once again, I am very thankful for your excellent work presentation, and I will hand over to this session to the Professor Rajendra Aira. Thank you for your presentation.
Thanks to all. Thank you.
Yeah.
Thank you very much, both of you. Professor Dr. Neetu Chopra ma'am has expressed such a valuable research or put up such a valuable research in front of us. Thanks a lot. Now we are moving towards the technical session of paper presentation. We have selected only 2 papers to present here, and we are giving 10 minutes to present, 5 minutes, and 5 plus 1, 6 minutes only, because we are running out of time. And I think that we should have to limit our time. So first of all, I invite the chairman of this technical session of paper presentation, Dr. J.V. Sari sir. Dr. J.V. Sari sir, Kavaitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. And we have 2 paper presenters. Number 1 is Dr. S.D. Bagul, Pratap College, Amarnet. And he is working in sophisticated nanomaterial lab in Pratap College, Amarnet. And another one is Mrs. Prajakta Burgaonkar from Vikas College, Mumbai. Over to Professor J.V. Sari, sir.
Yeah, thank you very much. Very good afternoon to all of you. So as we know, there are 2 oral presentations in this session. The first presentation is by Dr. H.D. Bagul from Pratap College, Amalner. So without wasting much time, I invite Dr. Bagul for his presentation.
Thank you,
Dr.
sir.
Bagul, please.
Yes, sir. Thank you, sir.
Yeah.
I'm sharing my screen.
Yeah.
If screen is visible, sir?
Yes, yes. Please proceed.
I am HD Babul, Assistant Professor from College Amalner. My title of the research article is Effect of Preheating Temperature on ZNO thin films prepared by ultrasonic atomization and pyrolyzation techniques. Here, we have prepared the thin films of ZNO material by using the ultrasonic atomization and pyrolyzation technique. In a special way, I used the zinc nitrate as a zinc source to prepare films. 0.1 molar zinc nitrate solution I used. The quantity is 300 ml and put into the flask of ultrasonic atomizer and use the ultrasonic atomizer having frequency 2.1 to 2.3 megahertz to convert this liquid into the fine mist droplets and use the double zone quartz reactor furnace to pyrolyze this mist on the glass substrates. So the mist was pushed by the controlled air pressure from the compressor, that is a 20 liter per minute is the optimized air pressure we have used to get the well structured and uniform thin films. Here we have used the double zone quartz reactor furnace, and here we have attempted to change the first zone. This is first zone of the double zone furnace. Here we have changed. This is the technique we have used to prepare the thin films. This is first zone and this is second zone. This is the first zone and this is the second zone. Here we have changed the first zone temperature from 25 degrees Celsius to the 400 degrees Celsius in the steps of 100 degrees Celsius, and while keeping the second zone temperature constant at 100 degrees Celsius. And we have kept the glass substrate in this quartz reactor in line to the quartz reactor. So this is the ultrasonic atomizer which generates the mist, and here we have put the solution of zinc nitrate 0.1 molar and 300 ml. So this mist is pushed through the compressor, and we pass this mist for 30 minutes optimized to get the good films. So in this way we have prepared the thin films of first zone 25 degrees Celsius, second 200 degrees Celsius, 300 degrees Celsius, and 400 degrees Celsius, while keeping second zone constant at the 500 degrees Celsius. This is the photograph and this is the block diagram of the system we have used. So these are the XRD patterns of the prepared thin films. Here clearly it is indicated that the X-ray diffraction pattern of the films are matched with the standard XRD pattern of ZNO material. So in this way the material is confirmed. And these are the FESM micrographs of the prepared thin films. And from this images, it is seen that the ZNO material is deposited in rod-like structures. And most of the rods are vertically aligned to the glass substrates. So it is seen that the film is highly porous. So this porosity could be used for the gas sensors because the ZNO is the very good gas sensing material. So this film may be used for the gas sensors. So these are the UV visible absorption spectrographs of the prepared thin films, and it is seen that the age of absorption shifts by changing the first zone temperature, because the mist is dried in the first zone by changing the temperature. We are trying to optimize the gradient, which gradient is better to get the good nanostructured material. So here from this UV visible absorption spectrum, it is seen that the absorption age is shifted by changing the first zone temperature. So from this absorption spectrum, the optical band gap is measured, and it is seen that the S2 sample, which is prepared by keeping the first zone at 200 degrees Celsius and second zone temperature at 500 degrees Celsius, which gives the large band gap, that is 3.32 electron volt. So in this way, the optical band gap is measured, and we have measured the photoluminescence properties of the prepared thin films by using photoluminescence emission, and all films are excited at 420 nanometer and see the emission spectrum of the films, and it is seen that all the films gives the good visible emission, good emission in the visible region. So this material, and one of the reported article has given that if the emission is in visible region, so that may be due to the internal interstitial defects, and such as oxygen vacancies are due to the presence of oxygen vacancies. So if the material is more oxygen deficient, so that material could be a good material for the gas sensor. So this may be the indication for the material it could be used in the gas sensor. And last summary and conclusion, we have prepared the ZNO thin films successfully by using ultrasonic automation and pyrolysis techniques by changing the first zone temperature from 25 to 200, 300 and 400 degrees Celsius while keeping the second zone at 500 degrees Celsius. APSM images of the ZNO thin film showed that the topology changed due to the change in the preparative conditions. FESM images of the thin film showed that the ZNO thin films consist of the rods. The bundles of the nanorods were observed to be randomly distributed. Due to this, the thin films are highly porous in nature. The rods deposited on the surface of the films are seen to be mostly vertical to the surface of the substrate. Such films are reported to be technologically important and attractive. The size of the crystallites associated with the films was observed to be dependent on preparation condition. The films prepared at the first zone at 200 degrees Celsius and second at 500 degrees Celsius gives the smallest crystallite size, having 9.87 nanometer, which is measured from the Debye-Scherrer formula as compared to the other preparation condition. The band gap energy of the films was observed to be dependent on the preparation temperature. The absorption age was found to be shifted to the lower wavelength side as we increase the first zone temperature from 25 to 400 degrees Celsius. Photoluminescence emission spectrum of the films are measured and found in the visible range, which may be due to the presence of the defects on the ZNO rods, and the prepared thin film material may be used in solar cells due to its high emissivity in the visible range. And thank you for listening me.
Okay, thank you very much, Dr. Bagul, for your nice presentation in a very limited time. So we may take one or two questions from the audience. The session is open for questions. I request the audience.
Sir, there is a question in the chat box.
Yeah, I will take it. The question is from Dr. Sham. Crystalline size 9.37 nanometer is your calculated value or standard value?
Yeah, I have measured from the XRD pattern of the films and by using the Debye-Scherrer formula.
Yeah, it is a calculated value.
Calculated value.
Yeah. Is there any question from audience? Okay, I have one question, Dr. Bagul.
Yes.
So you discuss about the effect of the temperature in first zone on the structural and optical properties.
Yes.
So which parameter is more important? Is it the absolute temperature of the first zone or the temperature gradient in the path?
Yes. First zone temperature is also very important, sir, because the mist is depends on the how it dries fastly or slowly.
Okay.
It depends on the first zone temperature, because second zone we have used to pyrolyze.
So is the temperature gradient also plays some also plays some role in the determination of the properties, or that is not much important?
Because we have to study how the droplets are dried. Because suppose sometimes we were expecting that suppose the droplet is dried outside, but if the water content is, if it is inside, what will happen? That droplet may expand in the second zone due to the high temperature, like balloon. So because outer side will be the dried covered, so it may expand. So due to that, we can say decrease the particle size, because due to expansion, the mist may blast.
Okay.
Okay.
So you mean both parameters are equally important?
Yes, sir. Yes, sir.
Okay. Okay. Yeah. So if there are no other questions from the audience, let us thank Dr. Bagul for a very nice presentation. Wish you all the best.
Thank you, sir. Thank you for listening. Thank you.
Yeah. So the second presentation in this session, oral presentation, is from Miss Prajakta Borgavkar. She is from Vikas College, Mumbai. So I invite Miss Prajakta for her presentation.
Thank you, Sali sir.
Yeah.
Yeah. Good afternoon to all the dignitaries present here for this international conference. Myself, Mrs. Prajakta Borgavkar, Assistant Professor at Vikas College, Vikhroli, Mumbai. I would like to present my paper. Just give a second, I will share my screen. Yes, is my screen visible?
Yes.
Okay, yeah, thank you. So, see, my presentation topic is on thin films and photoelectrochemical studies of zinc selenide and cadmium selenide alloys. See, in the today's world, as we have seen various presentations and talks, great talks based on thin films. So in this today's technology, several thin films have been assuming increasing interest for various optoelectronic applications. Among these various semiconducting materials, zinc selenide and cadmium selenide are found to be promising elements for this photoelectrochemical cells. Coupling of zinc selenide and cadmium selenide could give different materials with different band gaps, which may be suitable for the accomplishing two tasks, increase absorption of solar spectrum and enhance resistance towards the photocorrosion. So we selected to synthesize pure zinc selenide and cadmium doped zinc selenide thin films to study the various characteristics. From different techniques and methods, we selected the chemical bath deposition technique, as it is a very simple method. It is very convenient and inexpensive also, and it controls or it permits easy control and stoichiometry of chemicals. It works on the.
Can you go to the presentation mode, please?
Just a minute, huh?
Yeah.
Sorry, I could not get that. Is it okay now, sir?
Yeah, it's okay now.
Yeah, sorry. I hope now you can see my slides clearly. Yeah.
Yes.
Some different techniques we have selected the chemical path deposition technique, as it is very simple, convenient and inexpensive technique. It works on the principle of ion by ion condensation and is capable of producing uniform homogeneous layers in a controlled composition. For this, we selected the AR grade zinc sulfate, cadmium sulfate, and sodium selenosulfate was prepared, and they were taken in the proper stoichiometric ratio, and the deposition parameters like temperature, time, pH, all are optimized to get good quality of the thin films. This shows the simple experimental arrangement for the CBD technique, which is designed in our lab. This is the substrate holder. Here is one substrate, another holder. We can attach it. During my work, I attach here another holder with a stainless steel substrate and one with a glass substrate. So simultaneously, I can deposit both the films. You can see the pure zinc selenide structures, selenide thin films are white in pale white in color, whereas when cadmium is added to it, they becomes little bit orangish. We studied various characteristics of the thin films. This shows the X-ray diffractograms, which suggests that the films are polycrystalline with a prominent 111 cubic phase, which was observed in both the cases. The crystalline size was calculated by the Debye-Squarer method, which shows increase in its value from 120 angstrom unit to 144. When cadmium is doped in the zinc selenide lattice, the internal microstrain, which is the disagreement of lattice created during the deposition process, that decreases for cadmium zinc selenide. Also, the dislocation density decreases. Then the surface morphological studies were done using FEG-SEM at SAIF, IIT Bombay. The micrograph shows that the grains are spherical in size for zinc selenide, which the size increases, the grain size increases when cadmium is doped in it. The energy dispersive X-ray technique shows the elemental composition of these deposited films were nearly in agreement with the basic ingredients which are taken in the bath. The optical studies shows that a shift in the absorption edge towards the higher wavelength side and a high absorption coefficient of the order of 10⁴. The energy band gaps were decreased from measured from Tox plots, and it gives the decrease in its value from 2.81 to 2.27 for zinc selenide to cadmium zinc selenide thin films. To produce the high efficiency solar cells, absorption spectra of wide range of visible light spectrum is important to increase the light harvesting capacity of the solar energy. So the zinc selenide and cadmium zinc selenide deposited on the stainless steel substrate were used as a photoelectrodes in this photoelectrochemical cells. The charge transfer process across the semiconductor electrolyte interface results in a net current flow through the junction. The current voltage characteristics for these films as photoelectrodes were studied at room temperature in dark and also illuminating it with a light of 20 milliwatt per centimeter square intensity. You can see here both the films, both the electrodes gives diode-like rectifying type of characteristics. We can see increase in the open circuit voltage VOC and short circuit current were observed for cadmium doped zinc selenide thin films. The output parameters of the PEC solar cell, that is field factor, efficiency, quantum conversion efficiency, were calculated. And it shows that from this table, we can see that the efficiency increases from 0.176 to 0.435 up to 0.435% for cadmium zinc selenide thin films. So with this various characteristics, I would like to conclude that doping 50, we tried with the 50% of cadmium in zinc selenide. We could get more stable ternary alloys to develop photosensor material with ideal band gap and enhanced conversion, quantum conversion efficiency. So up till this, we studied these for the various characteristics. My proposed work is we are going to study the capacitance voltage characteristics, optical, thermal, and other characteristics of this PEC cells. And also we are going to try different doping concentrations of cadmium to see how to get the better conversion efficiency to use this as a photoelectrodes. With this, I would like to thank for giving me the chance to present here. Thank you.
Yeah, thank you very much, Borgaonkar madam.
Thank you, sir.
So yeah, you presented your work very nicely in a limited time.
Thank
So
you, sir.
yeah, now your session is open for question and answer. So I request the audience to ask if you have any question on this talk.
Namaskar, madam.
Yes, sir.
Yeah. You showed absorption spectra of ZNAC and CDZNAC.
Yeah.
But from band gap values, it seems something is reverse. Can you once again explain, please?
Yeah. Just a minute. Yeah. See, the band gap for ZNAC is greater than that for the cadmium doped zinc selenide.
Absorption spectra, madam.
This is the absorption spectrum.
So, yes, madam. Now, for CDZNAC, the absorption edge is around 400 nanometer. Yeah.
Yes.
And for ZNAC, it is around 400 and something.
Yeah.
So,
correct.
I think ZNAC should have larger band gap than CDZNAC.
That is true, sir. We got the larger band gap for zinc selenide, and when the cadmium is doped in it, the band gap little bit reduces.
Yeah, then the absorption edge should be at higher wavelength, madam, because 1240 divided by the wavelength, no? So you will get the band gap value. So if you divide with this way, in this way, then the values could be reversed. I think so. So I don't know exactly what is wrong, but if the band gap is lower, then the absorption edge should be at higher wavelength.
Higher wavelength.
Okay, I think that must be here. Maybe there may be wrong. Naming may be wrong. I think so.
Yeah, maybe something we need to check. Yeah, that is my only concern.
I think while making the graph, the naming is not wrong. I think.
Maybe. All right.
Yeah. Sorry for that. Thank you for. Thank you for naming it, highlighting it. Thank you. Sir.
Yeah, no, madam. I think your work is very good. I am very happy to see this work is very nice.
Yes.
Just I had a visual query. Yeah.
Thank you, sir. Thank you
madam.
for
Thank you
pointing
very
it. While naming it was wrong, I think so.
All right, madam. You can correct it later on. No problem.
Yeah. Sure.
Yeah. Is the
Can I ask a question, sir?
Yeah. Yes, sure. Please.
Yeah.
Yes, sir.
Dr. Bharat Patil from Akkal College, ma'am. I have one question.
Yeah.
Yeah. Can we use these thin films for the photocatalytic treatment for removal of dyes or wastewater treatment? Because I belongs to chemical background. That's why I am asking this question.
Yeah.
Can we use these thin films for the use of photocatalytic treatment for removal of dyes or phenols like this?
Yes, sir. I have seen the various papers based on this during my research work. I saw some papers in which these films are used for water purification also.
Okay. Thank you,
Yes.
ma'am. Thank you.
Yes. Thank you, sir.
Yeah, one last question from me, madam.
Yes, sir.
What is the exact role? You showed that due to doping of cadmium, you observed some improvement in the property. I mean,
Yes.
reduction in the lattice strength, then reduction in defect density. So, what is the exact role of cadmium when you dope it in zinc selenide?
Yes. When cadmium is doped in the zinc selenide, the structural properties improved. We can see the structural size increases, right? The grain size increases, the dislocation density, microstrain or get decreased, as well as we get more efficiency, quantum conversion efficiency also increases. So we can use it as in the photoelectrochemical cells. We are trying to get different higher efficiency by trying with the different concentrations of cadmium also.
No, I was just trying to understand because cadmium has a higher atomic radius than zinc.
Correct.
So even then, what you observed is that there is a reduction in strain and reduction in defect density and so. So I was just thinking about
that. Means when the cadmium is added in the zinc selenide, it try to replace or it try to relocate the crystal lattice so that the band gap will get decreased as well as the efficiency increases.
All right. Yeah. So if there are no questions, other questions from the audience, let us thank Prajakta Burgaonkar madam. Thank you very much, madam.
Yes, thank you, sir. And thank you, Bagul sir, for pointing out that also. Thank you. I will rectify it surely.
Okay, so with this, we end the oral paper presentation session in this conference. So I thank you. I thank all the participants and the speakers also for attending this session. So I hand over the session now to the organizers.
Thank you very much, sir.
Yeah.
I express my sincere thanks to the chairman, Dr. Sali sir, and both the presenter, Dr. Mahavir Singh and Dr. Neetu Chopra ma'am. Thanks a lot. Thank you very much. Now, we are going to have one small guest lecture of our guide and guru, a source of inspiration for us. Let me invite Principal Dr. A.P. Karnar sir. I have been watching since morning that he is continuously attending the meeting and observing all these things. So I request Professor Dr. A.P. Karnar sir, who is also a Senate member, Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon, to offer his talk. Over to Karnar sir.
Am I audible, sir?
Yes, you are. Welcome.
Navodaya Shikshan Sanstha's Uttamrao Patil Arts and Science College, Dahivel, organized a one-day international conference by Department of Physics on advances in material sciences, applied sciences, and engineering. Respected chairman and patron of Navodaya Shikshan Sanstha, Honorable Sahib Patil, Honorable Inaugurator and my friend, Principal Dr. R.S. Patil sir, who is Dean of Science and Technology Faculty, Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. Guest of honor, my friend, Principal Dr. R.R. Aire sir, Honorable resource persons, respected members of management, Navodaya Shikshan Sanstha, Honorable Chairperson of this international conference, my friend, Principal Dr. Suresh Aire sir, convener of this conference, Professor Dr. Rajendra Kumar Airrao, co-convener Dr. Sachin Jilandre, Professor I.U. Sheikh, all chairpersons of different sessions, Professor Gunwan Sonone, Professor Sadi, Professor Sudham Chauhan, teaching and non-teaching staff of Uttamrao Patil Arts and Science College, Dahivel, and those who have made this conference very successful and wonderful, all dear participants. At the outset, I wish happy Ganesh Chaturthi to all. And on this auspicious occasion, this Uttamrao Patil Arts and Science College organized international conference virtually. So at the outset, I congratulate the management as well as honorable principal, coordinator, convener, co-conveners, and teaching and non-teaching staff of this college. Because organizing international conference, and that too on recent trends, that is on advances in material sciences, applied sciences, and engineering. I mean, very relevant topic, sir, you have chosen. I mean, what is happening around the world in these three areas? I mean, working in rural and hilly area, tribal area, is itself a challenge. And organizing international conference and bringing stalwarts in this international conference, this is a great challenge. But you have done it very successfully. That's why the management of this college and honorable principal and his team, these are congratulations. And that's why I congratulate you, sir, on this occasion at the outset. I mean, this conference, for me, I mean, I'm a man of literature. I'm a student of literature. For me, it is a glance to look at, I mean, advances, scientific inventions, which are going around the world in three areas. I could enjoy, because I am not the person who is attending this conference just for the sake of telling 5 minutes. I have been attending this conference since 10:30 a.m. in the morning. Though it is science conference, though it is about the recent trends in these three areas, but I wanted to know what is going on around the world in these three areas. Sir, you have really succeeded in making this conference very successful. What happens? Generally, we live at the east, but look at the west for scientific inventions and scientific discoveries. Generally, it happens. I mean, when we organize conference, I mean, is the conference useful for the teachers, those who are working in remote areas, those who are working in urban areas, those who are working in universities, those who are the prospective researchers, those who are prospective teachers? For all these stakeholders, this conference has become very much successful. I mean, resource persons, those who are from the soil, and those who are doing great work in Australia. I mean, Honorable Professor Dr. Prashant Sonar, Honorable Professor Mahavir Singh. I mean, the persons, iconic persons, sir, you have presented. And that's why, I mean, we live at the east. We have great thing. I mean, even in science at the east, at every time, we need not look at the west. In developing scientific approach, generally what happens? What is happening around us? That is neglected. And what is happening abroad? What is happening outside India? What is happening at the west? It is considered. But I tell you 2 or 3 examples. And these examples are, say, the renowned poet Kalidas wrote a poem on cloud. That poem is known as Meghdut. I mean, a poem can be written, a letter can be sent through the cloud. Poem can be written on the cloud, entitled Meghdut. I mean, this idea, this thought, which elaborated and presented through the poem Meghdut, considered seriously, a serious thought was given to this poem. Definitely, SMS which we send today, videos we upload today, this technology might have come in India first if we had given serious thought to the poet Kalidas and his poem Meghdut. The second example I tell you, that of Ramayana. In Ramayana, after defeating Ravana and after making Bibhishana the king of Lanka, Prabhu Sri Ram was returning to Ayodhya. Why is returning to Ayodhya? The plane which he used, that plane was 8-storied plane. 8-storied plane. Now we talk of jet airplane. That airplane is having 3-storied. One is economic class, second is business class, and the last is the class which is last is the part which is used for luggage. I mean, these three tire airplane is also a big discussion. But we had such a thought, we had such an idea even in Ramayana, in ancient epic. And Prabhu Sri Ram came by that aeroplane. It had 8-story. It was 8-storied plane. If we thought about this idea very seriously, I mean, the invention of aeroplane would be to our credit, would be to the credit of India. Again, one more example I give you from another great epic, that is Mahabharata. We all know Mahabharata. We all know the war of Kurukshetra. It was between Pandavas and Kauravas. And Dhritarashtra was away from Kurukshetra. He was away from war. And he was a blind person. Being a blind person, he could not see the war. Even he could not imagine the war, though he was the king. But Sanjay in Mahabharata showed him what happened in Kurukshetra. What happened there exactly? He used to describe, he used to narrate, he used to present as if visually. I mean, this was the dialogue, this was the conversation between Dhritarashtra and Sanjay. I mean, what was happening on that battlefield of Kurukshetra between Pandavas and Kauravas? The first live telecast was done by Sanjay in Mahabharata and presented to Dhritarashtra. I mean, this first live telecast, if a serious thought was given to this first live cast made by Sanjay in Mahabharata to Dhritarashtra about the battle of Kauravas and Pandavas, I mean, Doordarshan telecast and television would be to our credit. But what is happening around us? Sometimes we see it, but we do not look at it very seriously. We do not treat it as the scientific idea. It can be the idea. It can do comfort to people. It can make the life comfortable of the people. I mean, even simple ideas which are available in our great epics, in our ancient literature, in our ancient life. I mean, even Vedas, in Vedas, whatever we have in India, whatever we have for us.
माझ्या मते रेंज गेली त्यांची.
Let's wait a little bit.
रेंज मध्ये नाही येते मला.
Oh.
He is disconnected.
शेख सर फोन करायचा का त्यांना?
हो सर. हा डिस्कनेक्ट झाले सर तुम्ही. हॅलो.
Hello.
We are sorry, due to some technical problem, Dr. A.P. Khairnar sir disconnected from the Zoom meeting. Now, let us move forward. We are at the concluding session. I request our principal, Dr. S.C. Ahire sir, to offer presidential remark or the chairman's remark. I request Professor Dr. S.C. Ahire sir. Over to Ahire sir.
Thank you, sir. Welcome to good afternoon, everyone. It gives me an immense pleasure to share you that Department of Physics, Uttamrao Patil Arts and Science College, Dahivel, has successfully organized one-day international conference on advances, material science and applied science. It clearly seems that we can use modern technology in rural and tribal region also. Dear friends, our college is located in tribal and remote area. Due to COVID pandemic, we are able to organize such international conference with the help of technology. Small college like us got an opportunity to organize the events. The conference help us to update the knowledge of faculties and researchers in the field of science and technology and engineering. I take this opportunity to express my thanks to affiliated university and our patrons institute, now the Shaikshanik Sanstha's Dhule, For that encouragement and guidance to Honorable E. Vayunandan, Vice Chancellor KBC NMU Jalgaon, Honorable Professor B.V. Pawar Sir, Pro Vice Chancellor KBC NMU Jalgaon, Honorable Chairman of our Institute, Bhausaheb Arvind Manikrao Patil, and Board of Directors is very essential. I express my sincere thanks to Principal Dr. R.S. Patil, Dean, Faculty of Science and Technology, for his cooperation, boosted our confidence by offering valuable guidance. I express my gratitude to Honorable Dadasaheb Dilip Ramu Patil for his gracious presence and encouragement to us. I take an opportunity offer my sincere thanks to Honorable Directors Navodaya Shaikshanik Sanstha's Appasaheb Vasantrao Patil, Vasantrao Bachcha, for sparing and valuable time to guide us. I am very thankful to Vice Chairman of our institute, Honorable Nana Sahib Rajan Manikrao Patil, Honorable Director Dada Sahib Krupetji Nandre, Honorable Director Satyajit Patil for their support and guidance. I feel privileged and proud of to say that we an eminent guest speaker from Queensland University, Brisbane, Australia, Honorable Professor Prashantji Sonar. Although he is working abroad, he is a man of our land. He has explained the topic of very fluently and objectively. Moreover, Honorable Professor Dr. Mahavir Singh, Himachal Pradesh University, Professor Dr. Neetu Chopra, Jalandhar, Punjab, Dr. S.D. Bagul, Pratap College, Amalner, Prajakta Bodgaonkar, Mumbai, and our neighboring colleges principal and our backbones, Principal A.P. Khairnar Sir, Adarsh College, Nijampur, and Principal R.R. Aire Sir, HGP College, Sakri. I express my sincere thanks to our all speakers who delivers their valuable talk and enlightened participants, our participants. I am thankful to Professor Avinash Agrawalji, Bareilly, Professor Gunwanji Sonavne, Parola College, and Professor J.V. Sali Sir, KBC NMU Jalgaon, for our excellent role as chairman of various technical sessions. I also congratulate conveners of this conference, Professor R.B. Rao, co-conveners J. Nandre Sir, and ICRA coordinator, Professor Ayu Seth, for their endeavors. I am grateful to all participants from all over the country and abroad. I am also thankful to organizing committee and teaching and non-teaching staff of our college. At last, I personally believe that the conference is successfully. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you. I think Khairnar sir has rejoined. Shall I ask him to, or I conclude the session? Hello, Khairnar sir.
Session complete, sir.
Okay. So now I request Professor Dr. S.J. Nandre, co-convener of this e-conference, to offer vote of thanks. Professor Dr. S.J. Nandre, sir.
Good afternoon. On the occasion of International Virtual Conference on International Conference on Advanced Materials Sciences, Applied Sciences and Engineering 2021. I, Sachin Dandre, here to express vote of thanks on behalf of organizing committee. I would like to express a deep sense of gratitude towards Chief Guest, Honorable Professor E. Vayunandan, Vice Chancellor of Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, Honorable Guru, Professor B.V. Pawar Sir, Pro Vice Chancellor of Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, for being with us, as well as their online presence on their precious views. I am also thankful to Chief Patron, Sri Bhausaheb Arvind Patil, President of Navodaya Shaikshanik Sanstha, Dhule. I would like to express my deep sense of gratitude towards the inaugurator of this conference, Honorable Principal Dr. R.S. Patil, Dean of the Faculty of Science and Technology of Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. Our inspiration, Sri Dada Saheb D.R. Patil Saheb, Member of Management Council, Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, enlightened us with the inspirational and excellent words. I am thankful to the Honorable Appa Saheb Vasantrao Bachcha, Director of the Navodaya Shaikshanik Sanstha, Dhule. Appa Saheb has delivered informative speech. I am also thankful to the Sri Nana Saheb Rajendra Patil, Vice President of Navodaya Shaikshanik Sanstha, Dhule. I am also thankful to the Sri Dada Saheb Rupesh Nandre, Director of the Navodaya Shaikshanik Sanstha, Dhule. I am also thankful to the Sri Baba Saheb Satyajit Patil, Director of Navodaya Shaikshanik Sanstha, Dhule. I am thankful to the guest of honor, my Guru, Principal Dr. Rajendra Aire sir, for his valuable support to the International Virtual Conference on Advances in Material Science, Applied Science and Engineering 2021. I am also thankful to the Professor M.S. Wag from Pratap College. I am also thankful to the plenary session first, Professor Prashant Sonar, Professor and Head of Department of Physics and Chemistry, Queensland University of Technology, Brisbane, Australia, for his excellent presentation and mesmerizing results. His presentation provides us a new guidelines for the participant. I am also thankful to the plenary session second, Professor Dr. Mahavir Singh, Dean of the Faculty of Physical Science, Himachal Pradesh University, Simla. He delivered the effective speech and his valuable guidance. I am thankful to the plenary session chairman, Professor Dr. Avinash Agrawal sir, Bareilly College, Bareilly, and Professor Dr. Gunwan Sonone, Kisan College, Parola. Also, oral presentation chairman, Dr. J.V. Shai sir, Department of School of Physical Science, Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, and my friend Dr. Sudham Chauhan, H.G. Patil College, Sakri, for their valuable time. I am thankful to the participants who presented their research work in oral presentation session, particularly my friend Dr. S.D. Bagul, Pratap College, Ammaner, Neetu Chopra Madam from Jalandhar, Miss Prajakta Borgaonkar, Vikas College, Mumbai. I am also thankful to the complimentary message given by the Honorable Principal Dr. A.P. Khairnar, Senate Member of Kavitri Bainabai Chaudhary, North Maharashtra University, Jalgaon. Knowledgeable information is given, valuable guidance and expertise. I am also thankful to our college principal and international conference president, Principal Dr. Suresh Aire sir. He gives very valuable speech and spend online time, and all the attendees who are present here online for this conference. I would like to express my gratitude towards the technical support team of this college, without whom this ocean seems impossible, particularly convener of this international conference, Dr. Rajendra Aire sir, Professor Ayush Sheikh, Professor H.J. Badane, Professor Dr. R.V. Karante, Dr. S.V. Boi, S.S. Boi, Dr. J.U. Patil, Dr. Mahendra Borse, Dr. S.S. Chevale, Dr. V.S. Patil, Dr. H.N. Biraris, Dr. S.Y. Gavi, Professor B.C. Gerte, Dr. S.A. Patil, Dr. A.V. Nere Madam, Dr. A.S. Marathe, Dr. S.B. Desle, Dr. Balchandra More, Dr. Yogesh Korde, Dr. Sandanchu, Professor Nilesh Khairnar, and all teaching staff of the Manikrao Patil Junior College, Dahivel. I am also thankful to the advisory committee members, non-teaching staff, electronic media, print media. Once again, I express my heartfelt thanks to all of you By the permission of the president of this conference, I declare that the conference is over. Thank you very much. Jai Hind, Jai Maharashtra. Thank you.
Thank you, sir. Thank you very much.
Thank you, sir.
Shall I end the meeting?
Okay.
Thank you, sir.
Live streaming बंद करा सर पहिले.
हाँ, लाईव्ह स्ट्रीमिंग बंद करतो बरं, एक मिनिट.
लाईव्ह स्क्रीनिंग बंद झालं असेल तर आयराव सरांचं अभिनंदन, नांद्रे सरांचं पण अभिनंदन.
बंद नाही झालं सर, एक मिनिट थांबा.
अहिरे सर, तुम्ही आमच्यावर जो विश्वास दाखवला त्याला आम्ही सार धरलो.
एकूण फिजिक्स डिपार्टमेंटचं अभिनंदन.
50% सक्सेस झालो सर आपण. अजून 50% सक्सेस व्हायचंय आपल्याला.
नाही छान झालं. 50% का बरं? 99% झालं सक्सेस. असं का बरं?
उरलेलं 1% मध्ये जास्त. उरलेल्या पण आपला 1% आपल्याला खरा कळस आहे.
10
सर उद्या होऊन जाईल, काही काळजी करू नका.
हो,
1% पूर्ण करून टाकू उद्या.
10 वाजेपासून तर 2 वाजेपर्यंत, 2 वाजून 10 मिनिटापर्यंत नॉनस्टॉप तुमचं जर कॉन्फरन्स आपलं चालतं आहे इथं, तर याला आपण 99% सक्सेस म्हणायचं ना.
नेव्हर सिंगल पार्ट इज अनसक्सेस और फेल्युअर. दिस इज अवर सक्सेस.
अरे सर,
हा
10 वाजेपासून लटकवून ठेवलं, उद्या काहीतरी पाहिजे.
उद्या 100%. फक्त ते आईराव सरांनी घरी राहून जायला नको.
नाही, आहे ना गोंडवाड्याचा कुलगुरू.
आणि सुदैवाने टेक्निकल पण प्रॉब्लेम फक्त खैरनार सरांचा जर सोडला.
नाही सर, त्यांचं बँडविड्थ कमी होती.
हा,
नांद्रे सरांची पण याला बँडविड्थ कमी होती.
आता कमी झाली होती.
बँडविड्थ कमी होती.
हा, आता कमी झाली
त्यांचा
होती.
प्रॉब्लेम, त्यांच्या डिव्हाइसचा प्रॉब्लेम.
हा, पण खूपच छान झालेत सर्व सेशन. अतिशय टेक्निकल सेशन तर खूपच चांगले झालेत. आम्हाला कंटेंट माहित नाही, पण प्रोसिजर माहित आहे. फक्त प्रोसिजर बघतो त्यावर असं दिसतंय ना, तर खूप चांगलं झालं. कंटेंटचं काय कळलं नाही.
काय मिळालं त्याच्यापेक्षा एक इव्हेंट झाला हे महत्वाचं.